So very good morning, my dear friends. So yesterday I completed the complete bending stress in the beams. You have completed. We are going to discuss the next, the torsion also will complete it. So I'm going to give the answer for chapter number 5. Chapter number 5. Question number 3 is Agra. We already done in the question. All these questions are done with the different numericals. Question number 4 is C. Question number 5 is C. Question number 6 is Bombay. Next, question number 12. We can use the shortcut method, can be used it. Average stress into area because width is constant. C. Question number 14 is going to be Delhi. Question number 17 is C. Next, question number 26. It is going to be C. Question number 28. Agra. And chapter number 6. Chapter number 6. Question number 26. Here you should use the strength criterion. Permissible stress is given in the question now. It is C. Question number 32. Is the rigidity criterion, is the strength criterion. What the strength criterion now? Maximum shear stress induced should be less than or equal to permissible. Here, maximum theta should be less than or equal to theta permissible. Yesterday I already given, but you have not done the numerical question. Only, but yesterday I explained with a solid, but here it is given as a hollow. I'm writing the geometrical properties for circular cross section. Already you mentioned material properties are given in the question. Geometrical properties should be remembered. Mostly you are going to come across the circular. Only beams are non-circular. Is about a thick circular. Thick circular. Capital D, I am taking the outer diameter, small d the inner diameter. For circular and square cross sections, only for circular and square cross sections, I about HCA, I about VCA are equal. Only circular and square. That's why simply I written I. I means what now? Both I HCA and I VCA. And once again what? Z about HCA and Z about VCA. Only for circular and square cross sections, moment of inertia and section modulus about HCA and VCA are equal. So it is the I HCA or VCA mean both are same. Is it Z about HCA or VCA mean both are same? That's why I not clearly mentioned now. But rectangular is going to be different. One is the BDQ by 12, another one is the DBQ by 12. Z is about now BD square by 6, DB square by 6. Only in case of circular and square both are same. Here K is about now ratio of inner diameter to outer diameter. This value is what now 1. As per my notation, K is the ratio of inner diameter to outer diameter. This will be 1, less than 1. Thick circular. Thick means D by T ratio. D by T ratio will be less than 20. D by T will be less than 20. Greater than 20 is what? A thin section is a thick circular. So mostly a default hollow means you have to go for thick only. Default hollow means you have to go for a thick. Otherwise, check the ratio of what? A D by T ratio. So in the question, if it is not mentioned thick or thin, and if the thickness is given, then you have to find out this ratio. Inner diameter to thickness ratio. If it is greater than 20, is a thick, thin. If less than 20, it is going to be thick. Is a thin. Greater than or equal to 20. Greater than or equal to 20 means is a thin. But the area pi dt here what the assumption is made now, y max is equal to d by 2 is taken now. But actually y max is what a d by 2 plus t. But since the thickness is very small, it is taken as what a d by 2. Here only most of their Z and ZP, they are going to make a mistake. Some students are what sir has made mistake. D cube means they will take the k cube, it is the k to the power of 4 only. How to get the Z now? This should be divided by y max. What the y max? Now capital D by 2. So this term will remain same. Similarly, how to get the ZP? J by outer radius. J by outer radius. So what the outer radius? Now capital D by 2. So you have to divide by capital D by 2 means this term will remain same. And how to cross check whether the equations are correct or incorrect now? But the k value for a solid, is 0. If it is going to mention k for solid is what? 1. K the ratio of inner diameter to outer diameter. K for a solid is K for solid is 0. If I put the K equal to 0, you will get the same now. Put the K is equal to 0, you should get the same values now. But strictly speaking, this D is about now mean diameter. This D is about a mean diameter, but I have taken the inner diameter. So strictly speaking, here all this case about a D the mean diameter, mean. But generally for design, always you are taking the what now? Your thickness already very small now. So the difference between mean diameter as well as inner diameter is very small. For design, entire machine design, you are going to consider this is inner diameter only. But some of the questions, if clearly given as the mean diameter, in the question is given as the mean diameter, you assume it as the mean diameter itself. Clearly mentioning the small d the mean diameter. But I have taken as the inner diameter because entire design, we are assuming the inner diameter and mean diameter are almost equal because thickness is very small. That's why I taken as a small d for entire machine design, welded joints everywhere now. We are taking them. But some of the objective examination, if they are clearly given mean diameter, if they are given as a thin section, simply diameter means you can take this small d only. If clearly mentioned what the mean diameter, assume this is a mean diameter. This will remain same now. So if the clearly mean diameter is given, you assume it as a mean diameter itself. Same thing, you prepare a tabular form. Same thing, you prepare a tabular form for non-circular section up to this only. We are having a torsion of only circular cross section. For remaining what now? Square, rectangular, triangular, hollow rectangular, SD. You write down up to this now. But yesterday I already given now. These two are required only for circular because we are studying the only torsion of circular. Torsion of non-circular is not there. So you can prepare a one more table continuation for non-circular. You write down only area, moment of inertia and section modulus. Z and ZP are not required in case of non-circular because your syllabus not having the torsion of non-circular. Only for square and circular, I about HCA, I about VCA are equal. That's why I written as I. When both are different, you have to clearly indicate it now. Z about HCA and Z about VCA are same. But rectangular, triangular, they are not going to be same now. Which square now? SSR, SD both. SS and SD both are same. Here square means SS and SD. Circular means all this now. Solid circular, thick circular and thin circular. Here the difference between the inner and the mean diameter is very, very small. Here I taken what now? So if it is the MCQ question, you can take anyone nearest one. But if NEAT questions are there, everybody is going to ask, sir, if NEAT question we are going to be more accurate up to the second or third decimal. There only, if clearly mentioned in the question as a mean diameter is given, then take the mean diameter. Already mentioned, my dear friend, decimals means they are going to ask to up to second decimal or third decimal. Already mentioned. Once again, you are asking Mr. Ram Kumar. They are going to mention in the question. Sometimes they are asking up to first decimal, sometimes they are asking up to second decimal, up to third decimal. If you ask the third decimal, if the fourth decimal is more than 0.5, then you make it as what now? Already I mentioned. Once again, you are asking the same now. It is not possible to answer each and that only I mentioned now. If when somebody is asking a query, please listen that query. It is not possible to answer what now? The problem is what now? When I am answering query of one of the friend, remaining all are going to be what now? Relax now. It is not my query. Then afterwards you are going to get the same query now. Already what now I have explained and you are asking the same thing now. If 200 students are there, 200 students are asking the same query. So this subject will already take the more time. It will take the more time now. I am not going to respond this type of queries now when I have already answered it. If it is the first time I can answer it, when I already answered it already for one of your friend and you are asking the same thing once again, what now? What is the meaning of this now? When I discuss, you will not focus or you will not attend it. And when asking what, when I am clearing the query of other friend, it is not my query. It is better to relax, better to what now? Go through the, let me spend some time on social media. Sir is answering what the query of my friend. It is not my query. Why should I listen? Suppose you are getting answer like this. If you ask the second decimal, you can go up to. If you ask the second decimal, you can do up to like this now. For non-circular, I have already written all now. But non-circular, you write down A, I and Z. Already rectangular you have studied now, square you have studied now. And somebody is asking, sir, please prepare the table for non-circular. You do it now, already I have written. Similarly, you prepare up to what the Z now. Mr. Guptamsh Kumar, please prepare the table for non-circular. Yesterday you already done a question. Yesterday I have given all the values now. Z values are given for all now. Yesterday one numerical question is given. For triangular, BH square by 24. Rectangular is given. Square is given. SD is given. Some you have to prepare it. Don't expect each and everything now. And mostly you are going to come across what now? Except beams. Bars are what now? Bars are going to be circular. Shafts are circular. Under axial loading chapter, we are in the circular. Axial loading chapter, you are in the circular. Torsion chapter also, you are circular. Only structural member like beams as well as column. But some of the columns also going to be circular. Some of the columns also circular now. But only beams are not circular. Beams may be what now? Maybe rectangular, maybe square, maybe triangular, maybe I section or maybe T section. It can be there. That you prepare it only up to Z, you prepare it now. Question number 6, chapter number 5 is about the 3 questions are likely to get it. In the workbook, it asks only 1 question, but 3 questions are likely to get it. It's a standard objective question. What is given now? A rectangular section, a rectangular beam is to be cut from a circular log. A rectangular beam is to be cut, A rectangular beam is to be cut from a circular log of wood of diameter capital D. What is the ratio of the sides of the strongest rectangular section? If somebody want to construct about a building, even villages, nowadays most of the cities, we are going for a concrete structures now. Most of the houses are concrete structures. We are in the concrete beams are going to be used now. Concrete beams are going to be used. Most of the houses, concrete beams are used now. But in the villages, as well as some of the foreign countries, the completely houses are what now? Residence is going to be completely wooden structure is going to be used now. Now I want to construct my house with a wooden structure. Then you have to provide a wooden beam. What the resource for the wood? From where you are going to get the wood? Tree. What the cross section of a tree? Circular. Cross section of a tree is circular. But what the drawback of circular? It will give the least section modulus. So when the section modulus is less, moment of resistance is less, then it is not a strongest beam. If the building should be about now, house should be about now, strongest one. Beam should be a strongest one. Means section modulus should be more now. Section modulus should be more now. Assume this is about now. This is a tree. This is called as what now? Circular log of wood of diameter D. If I can use it as a beam, what the drawback now? It is providing more material at the neutral axis. As you are going away from the neutral axis, material is decreased just like a SD. It is going to give the least section modulus. Yesterday you are given also. And yesterday I have also given some numerical calculation as to complete it now. So when the section modulus less, moment of resistance less, then beam is going to be about now. Not a strongest one. Now, if you want to make it as the strongest one, then what I have to do it now? You have to cut a rectangle. From a circular cross section, how many rectangles you can cut it now? So many rectangles you have to cut it. But you have to cut a rectangle in such a way that what now? Whose section modulus should be more? Depth should be more than the width. Now it's asking what is the ratio of the sides of a strongest rectangular section. This is called about a circular log of wood of diameter. This is about a tree. This is called about a circular log of wood of diameter D. So I cannot, as it is, cannot use it as a beam. So you have to cut a rectangle. You can cut a infinite rectangles. But you have to cut a rectangle in such a way that whose section modulus should be more. Depth should be more than the width. Now it's asking what is the ratio of the sides now. So 3 objective questions are possible. In the question is asking only ratio of the sides of a strongest rectangular section. 2 more questions are possible. What is the ratio of the depth of a strongest rectangular section to the diameter of circular log? Small d by capital D. Small d the depth of a strongest rectangular section. Capital D the diameter of circular log. Similarly, b by d. What is the ratio of the width of a strongest rectangular section to diameter of the circular log? This is what now? Circular log. So if I can use it as a beam, its section modulus is less now. Now you have to cut a rectangle. You have to cut a rectangle. How many rectangles you can cut it now? So many rectangles you can cut it now. This is what now? Like this, how many rectangles you can cut it now? Infinite now. Now if I am assuming what now? I am assuming that what this is the strongest one. This is called as what? A wooden beam now. This is a what now? It is also what? A beam. It is also wooden beam. But what the difference? This is what the cross section, actual cross section is circular. Now I cut it what such that the cross section is going to be a rectangle. Now I am assuming what now? What the advantage of this now? What the advantage of this rectangular or circular now? This circular is what now? At the neutral axis less, more material. Here more material. As you are going away from the neutral axis, what happens now? Material is decreasing in the circular. But here everywhere is the same. Here everywhere is the same. But in case of circular, what that no? What the drawback of circular now is providing the more material at the neutral axis. As you are going away from the neutral axis, what happens now? Material is decreasing. But here everywhere what the same. So this is about the strongest one. It will have the more section modulus will be there now. So I'm assuming this is going to be a strongest rectangular cross section. Strongest one. I was in this is what now. Somebody can also make it like this now. I've taken this much of depth. Somebody can also take like this now. You can cut a rectangle like this. You can cut the so many rectangles like this now. So many rectangles you can cut it now. I can make the depth is also like this now. You can also make the depth is like this. Or still you can make a depth like this now. So many rectangles you can cut it now. But you have to cut a rectangle such that what now? Whose section modulus should be more? Whose section modulus should be more? So this is what now? Strongest rectangular beam. that can be cut from strongest rectangular wooden beam that can be cut from circular log. This is what this black color one now. The black color one is about a circular log. Now what is asked the question now? This is depth. Depth. This is the width. Width. Now you have to find out the ratio of the sides. So depth should be more or width should be more. Which rectangle is better always now? Depth should be more than the what now? Always for beam, which one is better? Which rectangle is better now? Thick and narrow or thin and wider? Thick and narrow. So D by B ratio should be more than 1. But if you ask width to depth means what now? Ratio will be less than 1. Now, if this should be a strongest one, means what? The section modulus should be maximum. Strongest one means what? A section modulus should be maximum. So many rectangular beams, you can cut it with a different size now. But I don't know what the size now. Now you have to find out the dimensions, the depth and width, such that whose section modulus should be more now. This is the depth and this is the width. So this is representing what now? Means MR should be maximum. That is, how many rectangle can cut it same now? For all the rectangle, which one is same now? Material is same. Material is same means MR is proportional to Z. That Z should be maximum. Z should be maximum in what now? Whenever you want to get a maximum value, what you have to do it now? Differentiate and equate to 0. So now what you have to do it now? Write down the, that is section modulus maximum in what now? dz by db or dz by dd should be 0. So what is the section modulus of this rectangular section? What is the section modulus of this now? What is the section modulus of this rectangle now? You have to take it about Newton. Default you are taking the HC the Newton. This is a Newton, so you are going to take it now. So what the section modulus now? 1 by 6 b d square. 1 by 6 b d square. And that has to be differentiated and equal to 0. But there are two unknowns are there. Width is also unknown, depth is also unknown. Width and depth are both are unknown. So I'm taking this. So this rectangle I'm drawing here now. Only this figure I'm showing here now. Side view I'm showing now. Side view I'm showing now. What the circle is representing now? Cross section of circular log. Is the cross section of circular log. Cross section of circular log. How many rectangles you can cut it? No, so many rectangles. You can cut so many rectangles of different size now. But we need a strongest one. Section modulus should be more. Depth should be more than the width. So I am assuming this is the strongest one I am assuming now. Like this you can get the so many rectangles you can get it. Now I am assuming the strongest one. So this is a neutral axis. This is D. This is B. Strongest rectangular section that can be cut now. Now you have to do the section modulus. What is the section modulus of this? Now 1 by 6 b d square. But b is unknown, d is unknown. B is unknown and d is unknown. Now what is the relation between b and d? What is this dimension now? This dimension is capital D. So now b square plus d square is equal to, which is a constant, capital D is a constant. So from this one, then what is the section modulus here now? 1 by 6 b d square. So we can substitute here now. Now, the section modulus should be more means what now? differentiate and equate to should be section modulus should be more mean what maximum. Section modulus maximum means whenever you want to get a maximum value, you have to differentiate and equate to 0. So what is the differentiation of this now? If you differentiate and equate to 0. So from this one, b by d. So this is the first objective question. One option is given, 1 is to root 3 is given. So when the 1 is to root 3, the option now. If you ask what the ratio of the width of a strongest rectangular section to diameter of circular log. What is the ratio of the width of a strongest rectangular section to diameter of circular? 1 is to root 3. Check it what the one option is 1 is to root 3 is given now. Next. Now from 1. Now from this one you are getting is the second objective question. So 3 objective questions are likely to get for the same input data. Is the first objective question, this is the second objective question. So 1 is to root 3 is correct. Square root of 2 by 3 is correct. Square root of 2 by 3 when is correct now? Ratio of the sides as depth of a strongest rectangular section to diameter of circular. But in the question is asking ratio of the sides. Ratio of the sides. Ratio of the sides of a strongest rectangular section. This is the third objective question. So 1 by root 3 is correct, square root of 2 by 3 is correct, and square root of 1 by root 2. If the MSQ questions are there now, which of the following are correct? Which of the following are correct when strongest rectangular section that can be cut from a circular log of wood of diameter. So all the 3 are going to be correct now. First one is what now? Ratio of the width of a strongest rectangular section to diameter of circular log. Small d by capital D. Depth of a strongest rectangular section to diameter of circular log. Square root of 2 by 3. And ratio of the sides. 1 by root 2 or root 2. Or what you can write on this now? One by root 2 is correct, root 2 is also correct now. Ratio of the depth to width, root 2. So now you have to cut a rectangle in such a way that what now? We have to cut a rectangle in such a way that the ratio of these two should be 1. Suppose this is 100 mm, this depth should be what now? 141.4. So that rectangle will be about the strongest one. Strongest one. You can cut how many rectangles like this now? Is one rectangle, you can cut it. Like this, so many rectangles you can cut it now. But what about this rectangle now? This rectangle what now? Width is more and depth is less. This is called as what? This rectangle is called as what now? Thin and wider. So many rectangles you can cut it now. But always which rectangle you have to consider now? Depth should be more now. But this also depth is more. But out of these two now, which one is the stronger mean we don't know. For that only I taken an arbitrary rectangular cross section. Then write down the section modulus and differentiate and equate to 0. Then we'll get it now. Mr. Swaraj Pandey, you have given whatever is absolutely correct. In all the textbook, they will draw only this figure. But till now, I used to draw this only. They are going to reproduce my notes now. First time I drawn this 3D figure now. Now next time what now? They will reproduce this now. If I am going to do introduce, this is the first time I drawn this 3D figure in your batch only. Because they are copying. They are copying my information. Then always I have to modify. I have to update it now. So I will not vote now. Give a scope to vote now. If they are copying, but I am the vote now. Original, I have created. Therefore, I am going to further modification. I am going to do it now. Further, I will try to simplify the word understanding of the question. In all the batches, I used to draw like this only. Since I drawn like this, they will also draw it now. And most of the textbooks also draw this now. Year by year, what happens now? The quality of the students is coming down, but the complexity of the paper is increasing. I'm not telling everybody, most of the what now? It is not the mistake of the student. The colleges where you are passed out, most of the colleges and most of the private engineering colleges now, they don't have the good faculty, is not going to be there. Then when the faculty itself was not having the strong about the concept, then student also is not having the concepts now. So year by year, when I started in 2007, the same subject I completed, allotted hours was at that time 80. I used to complete 85, maximum 88. But the same subject now, 2022, after 15 years, offline batch is going up to 125, 130 hours now. I have to cover so many. At that time, 2007, I used to cover only up to 2006. Now when I am taking the 2022, I have to take care the questions up to 2022. For your batch, I have to cover up to the what now? This year 2022. So year to year what? A number of questions are going to be, some new questions are going to be there. As well as the what? Quality of the students are coming down because of the what now? Where they learned, the student, the teacher, they don't have the proper basics now. And some of the teachers, they will teach it also. But student will not bother now because unnecessary teacher is wasting time. My university examination, we don't know all this thing. Even if some of the teachers are going to teach it, definitely some teachers, they will teach the basics now. But student will not bother now. In the college, they will ask about now their seniors. Unnecessarily, sir is giving all this thing. Simply refer this previous papers. This sufficient, these are the important topics. Because at that time, we are going to focus only university examination sessionals. We don't have a long-term vision will be there now. These concepts are not required for university, but when I'm going for the GATE or ESC, most of students, they are going to take the advice from a student. He don't have what now. You have to take a advice. Suppose you want to what now. Second year itself, the student has to what? Decide it now. Second year itself, he has to decide it. You want to go for the GATE exam, you want to appear, or you want to go for the MS in the foreign countries. You have to take it. Those who want to do the MS in foreign countries, they should write down the GRE and GATE. Then they should take the advice of the what now? Your senior who has appeared for the, who is preparing for GRE and TOEFL exams now. But somebody's student is identified what now? I want to go for the GATE. Then you have to take the advice of the what now? Advice of the seniors who is preparing for GATE and ESC. But will not what now? Since a senior, we are going to take it now. Somebody is preparing for GRE and TOEFL now. And this student is want to prepare for GATE. He is going to take advice from him now. He don't know about, but since you are asking about advice, he will give some advice, he is going to give it now. So always take the advice, free advice are available. Take the right advice from a right person. So for the same question in the workbook, you write down like this now. In the workbook, question number 6, write down there now. Option B. For option B, so many times I mentioned now, multiple options are correct for the same input data. For option B, within the bracket, write down option B. Option B, small b by small d. Option B within the bracket, small b by small d. Next, option C. Option C, write down what option C is representing small b by capital D. Option C is representing small b by capital D. And create a one more option. Write down option E. Write down one more option E. That is what small d by capital D equal to square root of 2 by 3. So B is also correct, C is also correct, E is also correct, but three different questions. If you have the ratio of the sides 1:√2, ratio of the width to strongest rectangular section, width to what now? Diameter of circular log is 1:√3, and depth to diameter of a circular log square root of 2 by 3. I can do this question within 1 minute now. I will take this one, I will complete this now. Students are going to be happy. Question is completed now. Within 2 minutes, I can complete this now. I will take this one, I will do this now. But now I have taken almost half an hour question now. So proper explanation with what the other possible questions are going to be there. So that you can answer the what now any of the question. That's why so many times I mention, when you are solving any objective questions now, first identify the correct option for this given question. Then check it what now. For this given question, answer is what a B. Answer is what a B. Then you have to check it whether any possibility of A, C, D are correct. So if you can try for multiple options now, so that your preparation is going to be completed. Instead of doing the question separately now, with a one question, you can make the 3 or 4 objective questions now. In one of the engineering service paper, this was asked now, ratio of the depth of a strongest rectangular section to diameter of circular log, square root of 2 by 3. And some students are, sir, why you are doing the differentiation, sir? That I am not going to explain. Whenever you want to get a maximum value or to different, that is the basic is going to be there now. So always what a mathematics is what important now. Most of the students, but some students are what now? They will ask the question. In the offline, nobody will ask. In online, what happens now? Because we don't have a direct interaction. Sir, आपने डिफरेंशिएशन क्यों लिया सर, इंटीग्रेशन क्यों नहीं किया सर? They will ask this type of questions now. Now in chapter number 5 is left out with one more topic is shear stress in the beams. Shear beams are what always loaded with a TSL. Every TSL equal to what you have studied in shear force and bending moment. So whenever a TSL beams are under what? Simple bending. Pure bending means what you have studied in bending moment is constant, shear force 0. Pure bending means bending moment is constant and shear force 0. BMD the rectangle, SFD the line coincides 0. But simple bending, Whenever a constant point load is there, what you have studied now? One shear force and one bending moment is there now. Clearly explained now. Then it is not a pure bending. In presence of constant point loads or TSL, bending moment will vary. And bending moment variation is one order higher than shear force. So mostly beams are under simple bending. Mostly beams are under simple bending. Simple bending means shear force is non-zero. When shear force is non-zero, bending moment is going to be varies. So to explain that shear strength the beam concept, I need the SFD BMD is required. So I'm going to complete the remaining portion of this chapter. So the remaining questions you can complete it. It will not take more time. So that questions you can complete after doing the SFD BMD. I can do it, but for proper understanding what is required now. For proper understanding, you need the SFD BMD concepts are required now. So the remaining questions of chapter number 5, maybe around 7 or 8 questions are pending in the chapter number 5. For that one, you need the concept of SFD BMD. After discussing the SFD BMD that you are going to discuss now. At the right time, I'm going to into the topic now. Yesterday when I'm discussing the moment of resistance, we need the strength and rigidity criterion concept. That's why I introduced the concept of the strength and rigidity criterion. Now we are coming to the torsion chapter now. Here also I am doing all the basics, but some questions like shafts in series and shafts in parallel I am not doing. That I am going to discuss first. I am going to complete the bars in series and the bars in parallel. That the first chapter is there now. So here I am going to discuss only the torsion equation. Now I am going to complete the questions, the torsion equation derived assuming the pure torsion. So that question I am going to do it now. Pure torsion means what? The twist means the constant. When a pure torsion you are going to get it now. Two equal and opposite twisting couple applied to the extreme end. Now I am going to complete the chapter number 6. The questions which are under pure torsion. But if the shaft is not a pure torsion, then you need a concept of shafts in series and parallel. But for that one, better to understand the what now? Bars in series and parallel. So as soon as this topic is completed, then I will come to the first chapter. There you are going to discuss the bars in series and parallel. Then I will come to the shafts in series and parallel. Then same concept is for the springs in series and parallel. So once you are thorough with the bars in series and the parallel, then shafts in series and parallel, springs in series and parallel, same concept. But springs is not in strength of material syllabus. Springs is going to be in machine design syllabus is going to be there. Some students are asking, sir, you are not discussed the spring. That is going to be covered in the machine design. But those who are thorough with the bars in series and the parallel, for them, shafts in series and the parallel, springs in series and the parallel, or directly can do it now. So now I am completing the questions only under pure torsion questions. Almost 70% of the questions are 60% of questions are pure torsion will be there. Remaining are what? Now, when it is not a pure torsion, when a twist moment is not constant, then at that time we need the concept of shafts in series in the parallel. Those questions I am not doing. First I am going to complete the bars in series in the parallel, then we will come to this now. All the interrelated topics that I am going to discuss at a time now. Torsional shear stress in the shafts. This topic is important for mechanical engineering student now. When you are studying the machine design, shafts are going to be the design of the shafts. This is important now. Torsion equation for circular cross section. T by J is equal to tau T max. Tau T max means what? Maximum torsional shear stress upon capital R is what? Radius of the solid shaft. R naught is about the outer radius of the hollow shaft, which is equal to G theta by L. G theta by L. This equation is derived already what the day before yesterday I studied now. When I written about how we are getting it, torsion equation, bending equation valid under pure bending, torsion equation valid under pure torsion. How is the equation derived now? A prismatic member under pure torsion means applying the two twisting couples of equal magnitude opposite direction, and these twisting couples are formed due to what now? These twisting couples are formed due to two equal parallel opposite ETSLs. Bending couple is formed due to pure bending. You are going to get it what now? Pure bending is possible because of the what now? By applying two equal parallel opposite eccentric axial load at the two extreme ends. Pure bending is possible by applying two equal parallel opposite eccentric axial loads on the two extreme ends. Similarly, the pure torsion is possible by applying two equal parallel opposite ETSL, two equal parallel opposite ETSLs at the two extreme ends. Twisting couple is what? What you studied pure torsion means two twisting couples should be applied at the extreme end, but the twisting couple is formed due to what now? Two equal parallel opposite ETSL. But if you apply only one ETSL, what happens now? If you apply one ETSL, then you are not a pure torsion. Then you are going to get a one shear force and bendiment will be there now. ETSL equal to what you have studied now? One TSL plus one twisting couple. Due to TSL, you are going to get a shear force and bendiment. So if somebody will ask now, when you are going to get a pure torsion, mean what the answer now? Two equal opposite twisting couples should be applied at the two extreme ends. But how they are formed means what? The twisting couples are what? Formed due to two equal parallel opposite ETSLs. The equation is derived by assuming When you are studying the axial stress equal to P by A, sigma equal to P by A, change in length equal to PL by AE. But the first condition is studied, prismatic bar. Next, pure axial loading, same material. So whenever you are using this equation, first of all, it should be a circular and prismatic. But in case of axial loading, only prismatic. But here it should be a circular and prismatic. Next, pure torsion and same material. Whenever any of these conditions are not satisfied, if a tapered shaft is given, now which condition not satisfied? The prismatic is not satisfied. And sometimes twisting is not constant, sometimes material is not same. So at that time this equation not valid now. So before using this equation, first you have to check it, is it a circular cross section or not? Then it should be a prismatic, then the pure torsion, then same material. Whenever any of this condition is not satisfied, you have to split into number of shafts. Suppose a stepped shaft is given, means which condition not satisfied now? Prismatic is not satisfied. Then you have to split into number of shafts such that they should be, all the three conditions should be satisfied. Circular and prismatic, next pure torsion and same material. There only we need the shafts in series and the parallel is required now when these three conditions are not satisfied. What is the meaning of pure torsion you have studied now? Starting already you have studied the assumptions, 7 assumptions you have studied now. And those assumptions are valid for everything now. So, but here also 7 assumptions are required now. But when you are using this equation, check it what now? These conditions are not satisfied. Always what now? We are dealing with a what now? Static loading only. Self-weight is neglected. Equilibrium condition, that you need not check it because always default is what now? We are dealing with a static loading. Next, static equilibrium, self-weight is neglected. They're all common assumptions. You need not check it now. And we are dealing with the elastic torsion, that we are dealing with a what now? Member is what now? Elastic body, perfect elastic body. So that condition need not check it now. Their default is going to be satisfied. Only you have to check these conditions. Now that is what now? It should be first of all, member should be a circular and prismatic shaft. Next, shaft should be under pure torsion. And third one, even when you are going for the bending method also same. Even bending equation and axial loading equation. When you are using sigma equal to P by A, change in length equal to PL by A, what change you have to make it now? Only prismatic member. Only the equation for circular. Remaining all are valid for any cross section. So when you are going for a bending equation and axial stress equation, what change you have to make it now? Axial loading means prismatic bar. Bending equation means prismatic beam. Next, axial loading equation, bar should be under pure axial loading. And bending equation, beam should be under pure bending. Next, bar should made of same material. That is obviously the homogeneous isotropic material. And beam should made of same material. Beam should be made of same material. But probably I have not written this one, but I written for axial equation first day itself. We have written when you have written the sigma equal to P by N, change in length equal to PL by AE. Already written now. So whenever you are solving the problem, these three conditions you have to check it now. Remaining condition you need not check it now. What the remaining condition? Self-head is always neglected. Always it is going to be a equilibrium, static load. And member is about now. Member is undergoing what a perfect elastic body. And material obeys Hooke's law. So this you need not check it. The default they are going to be satisfied. Only you have to check it now. Only in this equation extra condition is this now. Circular. So apart from the 7 assumptions starting now, 7 assumptions, what the extra assumption here now? Pure torsion. 7 assumptions I discussed starting of the following assumptions are made while deriving the strength of metal equation. So what the extra condition here now? Extra assumption is what now? Pure torsion. Next, plane section remain as a plane even after twisting. Plane section remain as a plane even after twisting means the circular cross section remain as a circular. Circular cross section remain as a circular. Means the cross section is not going to be distorted. Plane section remain as a plane even after twisting. Circular cross section remain as a circular cross section. Sometimes the MSQ question in the workbook, one question is there MSQ. Which of the assumptions are valid in the torsion equation? So starting 7 assumptions, next new assumption is what now? Pure torsion, and next one is what now? Plane section. Plane section means what? A cross section. That circular plane section remain as a plane. Plane section remain as a plane even after twisting or torsion. The circular cross section remain as a circular. But if you use any other cross section, this assumption is not satisfied now. If you go for a rectangular section, it will not remain as a rectangular cross section after applying the twisting couple. Only circular cross section, only this assumption is satisfied. That's why the equation valid only for circular now. Plane section remain as a plane even after twisting. That assumption is valid only for circular. That's why the equation valid for circular. If you go for a rectangular cross section, that assumption is not satisfied. Rectangular cross section will not remain as a rectangular after applying the twisting. So that there you have to study the concept of torsion of non-circular. So why the equation valid only for circular mean what the answer now? While deriving the equation, we are making an assumption of circular cross section remain as a circular. That is what now? Plane cross section, plane section. Plane section means cross section. Remain as a plane even after twisting. Plane sections remain as a plane even after twisting. The circular cross section remain as a circular. But if you go for any other cross section, they are not going to be remain same. So that assumption is not valid for the non-circular. What the terminology used in the equation? Let me write down terminology, then I am going to take a figure. I will explain it now. Twist bended torque acting on the cross section of shaft. Twist meter torque acting on the cross section of shaft. What the definition of this now? Algebraic sum of twisting couples either on the right side or on left side. Twist meter at any cross section equal to algebraic sum of the twisting couple either right side or left side now. But how to calculate this now? At the driver shaft. Sometimes driver shaft means what, which is connected to prime mover, motor shaft, engine, IC engine crankshaft, prime mover shaft or driver shaft. At the driver shaft, the torque is a constant. Sometimes they are giving the prime mover shaft. Then how to calculate here now? Whenever a prime mover means what is going to be given, power is given. And prime mover shaft is rotating a constant RPM now. But driven shafts are what now? IC engine crankshaft rotating at the constant speed. But what about the automobile shaft now? Automobile shaft is what now? Your automobile what now? Two-wheeler bike now. Bike what now? Driven shaft. Bike shaft is not rotating a constant now. You are going a first gear, second gear, third gear, fourth gear now. National highway are going at the fourth gear. Suddenly hill road is going to be there now. Because the torque is going to be more now. Then automatically power equal to torque into omega. Power at the driver and driven machines are same. But at the driven shaft what now? When you are going on a suddenly hill road now, resisting torque is more. Torque required is more. Then automatically what you have to do it now? You have to reduce the speed now. We are coming to the first gear or second gear now. That's why always the gearbox is going to be used now. But driver shaft is always rotating at the constant speed. Motor shaft, engine shaft. So sometimes they are giving the what now? Driver shaft question is going to be given a driver shaft. In that case, directly how to find out the driver shaft means always what now? Power is given, RPM is given. Whenever a motor is purchased now, whenever you are going to purchase a motor and whenever you purchase a IC engine, what the specification will be there now? Whenever you are purchasing a motor, clearly they will mention what now? Power is so-and-so kilowatts and so-and-so RPM. So once you know the power and RPM, then directly can find out the torque now. But at the driven shafts, they are not rotating. That is about driven shaft, driven machine shafts. Simple example, automobile shaft. They are not rotating at the constant RPM. The RPM is going to be what? A change as per the requirement. When you are going on a flat road, the resisting torque is going to be what? A more now. Sir, less now. When the resisting torque is less means omega is what? A power equal to torque into omega. So torque is what? A power is constant. The torque is inversely proportional to omega. Since the resisting torque is less means automatically omega is more. There you are going at the fourth gear now. And suddenly hill road is going to be there now. We need about a resisting torque is going to be more now. Then in that case, we need about a more torque is going to be required now. Then in that case, we are going to reduce the speed. So the driven shafts are rotating at the variable speed. But sometimes what the driver shaft is going to be given now. Then at the driver shaft, how to find out the torque now. Yesterday you had done the two questions. Chapter number 6, last question, gate question now. They have given directly, power is given, RPM is given. Means it's nothing but about the driver shaft only. Power into 60. If this calculation is simple calculation, if this calculation incorrect, then remaining all the calculations, so many times I mentioned now, stress, strain, deformation depend upon the load now. Some students are going to make a mistake here itself now. It's a simple calculation. Mostly I'm in the Newton mm. Generally torque units are Newton meters. Newton, but I'm taking the Newton because always your dimensions are in mm now. So here, what this P? Power. What the power units now? Kilowatts. This is RPM. driver shaft speed RPM. Here this is N dash RPS, revolution per second, or heads. And once again this is in kilowatts, because generally what now, motor specification power is always mentioned in the kilowatts, is going to be mentioned now. And this is angular velocity. So by here multiply by 10 to the power of 6. Actually here unit should be watts now. So to convert this kilowatts into watt, to convert the kilowatts into watt, 1 10 cube. Another 10 cube is what? Converting the Newton meter to Newton mm. 1 10 cube is converting the kilowatts to watts. Another 10 cube is converting the what? Newton meter to Newton mm. Actually, suppose if I take the power, I assume the watts. And if I remove this now, if I remove this 10 to the power of 6, then the units are Newton meter. Actually it should be what now? Here watts, and here it should be Newton meters. So to convert that Newton meter to Newton mm, 1 10 cube, and to convert the kilowatts into watts, it is going to be one more 10 cube. Because sometimes they are giving the RPM, sometimes heads is going to be given, revolution per second or angular velocity is going to be given now. But this is possible only at the driver shaft now. Next, small r. The small r is what now? Same as the y. Yesterday bending equation. What the bending equation now? What the bending equation? Small, we are taken y. What the y now? Distance of a fiber from the neutral axis, or distance of a point on a cross section from neutral axis. That is either HC or VCA, depending upon the bending now. So here that y is replaced by small r. What is the small r now? Twisting couple about polar axis. Now this should be measured from the polar axis. What the small r? Don't use like this now. Use the small r like this. Don't use like this now. This you are using for the shear strain. Small r means you go for this only. Don't write down like this now, because this you are using for a shear strain. Don't use this notation for small r. This is for you are using a shear strain. Small r. Distance of a arbitrary point on the cross section from its centroid. Always polar axis coincides with the centroid. From its centroid or polar axis. Of the cross section. But in the bending chapter, what you are in a y? Y is equal to what should I write down? Distance of an arbitrary point on the cross section from its neutral axis, that is HC or VCA. But instead of a point, there you have mentioned in the fiber. For all the points on the fiber, y is same. For all the points on the fiber, y is same. So instead of point, you have mentioned as the what now? Fiber you have mentioned. Then capital R naught. This is just like a y max and x max. distance of a faraway this was explained when you are studying the section modulus definition now. Distance of a faraway point on the cross section every time I'm not writing the polar axis. Centroid and polar axis, what centroid is always coincide with the polar axis. Faraway point on the cross section from its centroid or polar axis. So which point is far away from the polar axis? No, any point on the periphery. Any point on the periphery. But in case of beam's case, what now? Where is y is maximum? Now, y is maximum at the, if centroid is exactly at the mid depth, y is maximum at the top and bottom is going to be maximum now. In triangular case, y is maximum at the top. T section, y is maximum at the bottom now. But this is what the distance of a faraway point on a cross section from its centroid. That is what any point on the periphery. That is any point on the periphery of the cross section. Next, J. J is what now? R square dA. Just now yesterday written what now? Y square dA. Y square dA. Integration of y square dA. That you are called as what now? Second moment of area of the cross section about its neutral axis, means about HCR VCA is going to be considered. But here what this represents, R is measured from where? Na polar axis. So what this R into dA? R is measured from where? Na polar axis. So what the R into dA? First moment of elemental area about polar axis. What the R square dA? Second moment of elemental area about polar axis. And this integration will give the what now? Second moment of area of a cross section. Second moment of area of a cross section about its polar axis. That only are called the polar moment of inertia. But every cross section we know the moment of inertia about HCA and VCA. Then how to get the about polar axis? By using the perpendicular axis theorem. So this is representing second moment of area of a cross section about its polar axis. We are in the short form PA. So this is only nothing but about now. Polar moment of inertia of the cross section. Polar moment of inertia of the cross section. And this will be obtained by using perpendicular axis theorem. This is obtained by what? The perpendicular. For every cross section we know the moment of inertia about HCA and VCA. It It is obtained by using perpendicular axis theorem. Is a cross section. And what the dot now? Centroid or polar axis is the polar axis. So this line is about now. What is this black color line? Radial line. Already studied the radial line concept now. What this a point? This distance about now, small r. What the small r you studied now? Distance of arbitrary point on a cross section from its centroid or polar axis. Polar axis. So like this on this line now, how many points are there? Infinite points are there. On this line, point to point on this radial line, point to point, what happens? Small r will change. On this line, there are infinite points are there. But point to point, what a small r will change. But why I taken these 3 points now? What the specialty of the black color point where r is 0? Where r is 0. What the blue color point? On the periphery, is far away. On this line, there are infinite points are there. What these black color points now? What the black color point? Where r is 0. How many points r is 0? Only 1 point r is 0. How many points r is 0? No, only 1 point. And what about this blue color point is far away. That is r is maximum. That is the capital R. Now what the specialty of all these blue color points? For all these points R is maximum. All these points R is maximum. So how many points R is maximum? Infinite point. For all this blue color point R is maximum. That is the capital R. Means they are all the far away from the centroid. They are all the points on the periphery. But Y is maximum at how many points? Now only at these 2 points. Y is measured from which axis? Now XX. Y is measured from the XX. So Y is maximum only at these 2 points. Y is maximum only at the 2 points. If the shaft is subjected to bending, if the shaft is subject to bending in vertical bending, if the shaft is subject to bending in vertical plane, now this will be the neutral axis. So where the bending stress maximum only at these 2 points, top and bottom. But here R is maximum at what now? Infinite points. Try to correlate now. Bending stress is proportional to Y. Bending stress is proportional to Y. But here torsional shear stress proportional to small r. Sigma B proportional to Y. Tau T is proportional to small r. Now here what the R value? Now 0. So tau T is 0. So how many points? Torsional shear 0. I'm going to prove it now. But I'm correlating what? A bending and the torsional shear stress. Bending stress is proportional to Y. Y is measured from which axis? No, neutral axis, that is the XX. So bending stress maximum at only 2 points, top and bottom. But torsional shear stress proportional to small r. At how many points? Torsional shear 0, only 1 point. This is only 1 point torsional shear 0 because R is 0. But how many point torsional shear stress maximum? Any point. So torsional shear stress maximum at any point on the periphery. So under pure bending, suppose this shaft is subjected to pure bending. Which one are the critical point? Only top and bottom. Only top and bottom. But if this same cross section subject to pure torsion, then torsional shear stress maximum, which one are the critical point? Any point on the periphery. So these points are important when you are going for the principal stress chapter. Now always the stress analysis is done at the critical point. So when a circular cross section shaft, when a circular shafts are subject to bendiment or twistment or both, beams are subject to bendiment, but shafts are always subject, both bendiment and twistment will be there now. Both bendiment and twistment is there. So you need the concept of what? Both bendiment and twistment. So when a circular cross section shaft is subjected to pure bending, bending stress maximum only at the 2 points. Only at these 2 points. Only at these 2 points. Because at this 2 point Y is maximum. Default I'm assuming the vertical bending. Vertical bending, which is the neutral axis now? HCA the neutral axis. But if the same shaft is under pure torsion, now which one are the critical points? Any point on the periphery. Pure bending case, only these 2 points are the critical. But pure torsion case, any point on the periphery is critical. Any point on the critical. Next, torsional shear 0 at how many points? Only 1 point. At how many points? R is 0. Only 1 point, that's the centroid. But how many points? Y is 0. Bending stress 0, any point on this axis. What you have studied? Bending stress 0 on the neutral axis. If I take any point on this neutral axis, that's the HCA. Bending stress 0. Bending stress 0 at infinite points now. That is what now? Any point on the neutral axis. Try to correlate with the bending and the torsional shear. Now, this is very important now. Bending stress 0, any point on this HCA. But torsional shear 0 at only 1 point. That is what? A centroid. Only at the centroid. Next. What the meaning of n? N means what now? They are on the neutral axis. Default amount is the vertical bending. So for all these points, bending stress 0. But torsional shear 0 at only one point, this point is the centroid. Bending stress 0, any point on the neutral axis. All these points bending stress 0. But torsional is 0 only at this point, centroid is 0. But bending stress maximum only at top and bottom. But torsional shear stress maximum at any point on this periphery. So critical points are the any point on the periphery because small r is maximum there. But bending stress maximum only at 2 points. In case of pure bending, only these two are the critical points. Both are very linear. Both are very linear, but completely different. This y is measured from neutral axis, that is HCA. R is measured from polar axis. If this is clear, then directly can answer it now. Next. So this point area I'm considering as about now dA. I consider small elemental area. This area is what now? dA. dA. Day before yesterday, I made a comparison between what I tried to say it now. When you are studying the principal stress chapter, I made a difference between the pure axial loading and pure torsion. And day before yesterday, you made a difference between pure axial loading and pure bending. Now we are making a comparison between pure bending and pure torsion. All these comparisons are important now. Clear, one of the very standard comparison, pure axial loading and pure torsion, you have done it now. Next, we have made a comparison yesterday, what day before yesterday, pure axial loading and pure bending, you have made it. Now we are making a comparison between what now? Pure axial loading and, pure bending and pure torsion. So this is what now? Element, this area is dA. So this dA into R, this is what, at what distance now? Small r. dA into R, what this is called now? First moment of this elemental area about which axis? The polar axis. R dA, first moment of elemental area. Now what the R square dA? Second time moment. Second moment of this elemental area about which axis? The polar axis. This is the polar axis. Then you want to get for entire cross section. Then you have to go for the integration. R square dA. Integration of R square dA. dA into R. First moment of elemental area about polar axis. R square dA. Second moment of elemental area about polar axis. Integration will give the second moment of area about the polar, that is the polar moment of inertia. In one of the gate paper, that first day clearly means this subject is completely interrelated. There is no independent. If you are going to study independently, you cannot understand the subject. The questions are all are interrelated. Then you don't know why you are studying. Unnecessarily you are going to get a confusion will be there now. And you will not enjoy the subject now. When you are studying and you are going to correlate it, when you are going to make a comparison, then you are going to enjoy the subject, and then it's going to be what now? You know what you are studying, why you are studying, and then you can answer any of the questions. Then machine design will become as simple. In one of the paper, there was a question is like this now. Second moment of area of a halo circular cross section. Second moment of area of halo circular cross section. Second moment of area of halo circular cross section about a centroidal axis which is perpendicular to plane of the cross section. Second moment of area of a halo circular cross section about a centroidal axis perpendicular to its cross section. About a central axis which is perpendicular to plane of cross section. 30% of students have left it now. What is asked now? Second moment of area of a halo circular cross section about a centroidal axis perpendicular to plane of cross section. Means asking indirectly what now? Polar moment of inertia. If you ask the polar moment of inertia, definitely everybody is going to remember it now. Polar moment of inertia means halo circular is what now? Pi by 32 d to the power of 4 1 minus k to the power of 4. Everybody is going to answer it. But it didn't ask the polar moment. It asked clear definition. They don't know what is the central axis perpendicular cross section. They simply remember the what now? I equal to pi by 64 d to the power of 4. They don't know what the HCA. They don't know what the VCA. They don't know polar axis. So clearly what the definition is given now. Second moment of area of a halo circular cross section about a central axis which is perpendicular to plane of cross section. 4 option is given now. Only 30% of students who is thorough with the, who has focused on the basics and the concepts and definition, they answer it. Remaining friends what now? Because they didn't understood now. They didn't understood now. Then left it. Why should I take it? Negative marking is going to be there. They left it now. So answer should be what now? Pi by 32 d to the power of 4 1 minus k to the power of 4. Otherwise, pi by 32 capital D whole to the power of 4 minus small d to the power of 4. Now what this line is called now? Fiber. The fiber. Now for all these red color points, which stress is same now? Bending stress is same or torsional shear stress same? For all these points, bending stress same. Because for all these points, y is same. That's why yesterday clearly mentioned now. Bending stress will not vary on a fiber. It will vary from fiber to fiber linear. But torsional shear stress will vary now. For all these 5 points now. If I can call the A, B, C, D, E. For all these 5 points, which one is same now? Bending stress same. But what about the torsional shear stress? Here it is maximum. Here R is maximum on the periphery. Here R is minimum. So when I am going from A to E, torsional shear stress will decrease. Torsional shear stress will decrease. For all these points, bending stress is same because y is same. Y is measured from which axis? No, neutral axis, that's the HCA. Default, once again I am mentioning, I am assuming the vertical bending. Once I have taken the HCA, the neutral axis means I am assuming the vertical bending. But in horizontal bending, what now? If it is given a horizontal bending, a shaft is subjected to pure horizontal bending. Which one are the critical points? These 2 points are the critical. If the shaft subjected to one bending couple like this, one bending couple like this, these are in which plane? Horizontal plane. Then at that time, which one the neutral axis now? VCA will be the neutral axis. Then which one are the critical points now? These 2 points are the critical. Everybody is going to take top and, sorry, you mentioned top and bottom. If the horizontal bending, this is a neutral axis. Now what the stress here? No, 0. Bending stress 0 here now. But everybody is going to take it what now? If you ask the bending stress at this point, sir, M by Z. M by Z is valid here now. But they will take the always blindly what now? HCA with the neutral axis now. If you ask at this point, if you ask the bending stress, a shaft is under pure horizontal bending. Now which one are the critical points? These 2 points are the critical point because of this is neutral axis. Now if you ask what the stress here, no, 0. Therefore I clearly mention neutral axis may coincide with either HCA or VCA. Beams default is what now? They are subjected to vertical bending only. Beams are always subjected to vertical bending. That's why in beams always you are taking the default to the HCA neutral axis. But shafts may be subjected to HTSL or VTSL. In case of shafts, either HCA will be the neutral axis or VCA the neutral axis. So you should be careful. In case of horizontal bending, if you ask the critical point, mean what they are going to mention top and bottom. They are not the critical points. At this 2 point, bending stress 0. This is a neutral axis. Now bending stress 0 to all these points. In that case, what should I mention now? Sigma B proportional to Y or sigma B proportional to X. This is valid in case of what now? Horizontal bending or vertical bending. This is in vertical bending. But in horizontal bending, this is a neutral axis. And this distance X or Y, X. Then you have to write down what? The sigma B proportional to X. So where the X is maximum now? Here and here now. So this is valid under what now? Horizontal bending. This is valid under what now? Vertical bending. This is under pure torsion. Now, for these 5 points, what happens now? For these 5 points, bending stress is same because they are at the same distance. Default, I am assuming what if nothing is mentioned, I am assuming the vertical bending. But sometimes you should be careful because shafts, they are also subjected to horizontal bending. But what about the torsion? For all these points, what R is different or Y is same? Y is same for all these points. Y is same. But R is different. R is to be measured from the centroid. Here R is maximum, capital R, it is on the periphery. So T by ZP equation valid here now. It is the maximum. So when I am going from A to E, torsional shear stress decrease. At E is what the minimum will be there. Out of all these 5 points now, maximum at A, at E is going to be minimum will be there. Simply you should know this now. That's all. And you should know what the R now. But they will not focus on the R now. So this is valid in case of vertical bending. This is a horizontal bending. This is a pure torsion. Now only I have to prove it what now? How we are getting this relation. That I am going to prove it, but simply remember this now. Who is Satya? Continuously there is disturbing sound is coming. Technical team kindly check it, G. Probably Satya from your side maybe a problem will be there. There is no problem from other side now. No other friends are facing this issue now. Mr. Satya, check from your end now. So I'm making about, once again making comparison now. A shaft is about, a shaft means once again default horizontal. When a shaft is under pure torsion and when a shaft is under pure vertical bending. Pure vertical bending. What the comparison now? Pure torsion. Any point on the periphery are critical points. Pure vertical bending, only these two, top and bottom, are critical points. Or what the conclusion now? First comparison, what do you have to make it now? Pure torsion, torsional shear stress proportional to distance of a point from its centroid. Torsional shear stress proportional to distance. Torsional shear stress at any arbitrary point is proportional to its distance from its centroid or polar axis. But bending stress is proportional to bending stress at any point. Bending stress at any point is proportional to distance of that point from the neutral axis. In vertical bending, which is the neutral axis? HCA, the neutral axis. Everybody is going to write down this only. Sigma B proportional to phi. But this is also valid. This is valid under what? Horizontal bending. This is valid under vertical bending. In all the textbook, they will write down this only. Because of what now? In the last chapter also I have written, but I have explained there also. Neutral axis may coincide with HCA or VCA. In vertical bending, it will coincide with HCA. Horizontal bending, it will coincide with VCA. But in the bending chapter I have taken, we have studied with respect to beam. Beams are what? Always vertical bending. But why you are discussing the shafts are subject to both vertical and horizontal, both are going to be there now. That's why I discuss this now. What the next now? Bending stress is maximum at only 2 points. Bending stress maximum at only 2 points on the cross section. In vertical bending, top and bottom. Horizontal bending at left and right. If I take this a left and this a right. Or if this is a cross section of profile plane. If this is a cross section of profile plane, then this will be about one is the front side, one is the back side. This is what now? It's the top and bottom. Top and bottom. And what about these two now? This will be back side and the front side. Now this is a neutral axis now. So in case of horizontal bending, this is a neutral axis. So these 2 points are critical. But in case of vertical bending, these are neutral axis, then these are the critical now. So bending stress maximum only at 2 points on the circular cross section. In case of vertical bending, top and bottom. In horizontal bending, extreme back side, extreme front side. Points on the front and back side, front and back side. This I have taken this about the front and this is the back side. Next. Bending stress 0 at any, first torsion. Torsional shear 0 at only 1 point, that is the centroid. Only 1 point centroid. But bending stress 0 at any point on the neutral axis. Any point on the neutral axis, that is in case of vertical bending, any point on HCA. Horizontal bending, it is what? Any point on the VCA. Horizontal bending, any point on the VCA. Next, what the other now? On a fiber, bending stress remains constant. Means if you take any point on this fiber, now bending stress is constant. But torsional shear stress will vary. Torsional shear maximum at A, when I am going from the periphery to inside, what happens? Now torsional shear stress will decrease. So on a fiber, torsional shear stress will vary, is the maximum. Only similarity is what? Only similarity is what? Pure bending and pure torsion is what? Bending stress also varies linearly. Torsional shear stress also varies linearly. That is only the similarity. But bending stress is what? Normal stress, perpendicular to cross section. Bending stress is normal to the what? Cross section. That is perpendicular to cross section. So bending stress variation cannot be seen here now. Bending stress variation where you can see it now. What the bending stress variation here, they're all becoming the dots and cross. In case of sagging, you are getting a dot cross here now. Here dot will be there. Hogging case, here you are getting a dot. Here the cross will be there now. So bending stress variation, you can see the two similar triangles here now. Front view you can see it. But torsional shear stress is what? A parallel. Torsional shear stress parallel will be like this now. So torsional shear stress variation also consists of two similar triangle. But that way two similar triangle can be seen in the plane of cross section. Bending stress variation consists of two similar triangle but in a plane perpendicular to plane of cross section. But torsional shear stress variation consists of two similar triangle on the plane of cross section. Two similar triangle can be seen now. But completely different. Only similarity is what? Both are varies linearly. Both are varies linearly. But completely different. What the different now? Bending stress is perpendicular to cross section in the direction of the polar axis. In the direction of the polar axis. But torsional shear stress parallel to cross section. Torsional shear stress parallel to cross section. That is in the direction of HCA or VCA. Torsional shear stress what now? In the direction of either HCA or VCA will be there. But bending stress is what? A perpendicular to cross section, that is polar axis. And bending stress variation consists of two similar triangles in a plane perpendicular to plane of cross section. But torsional shear stress variation consists of two similar triangles in the plane of cross section. It is parallel to cross section in the plane of cross section. Bending stress maximum at only 2 points in the cross section, either extreme top and bottom or extreme front and back. Extreme top and bottom, extreme front and back. But how to decide mean what? The vertical bending or horizontal bending? Vertical bending, bending stress maximum at the extreme top and bottom. Horizontal bending, bending stress maximum at extreme front and back side. But torsional shear stress maximum any point on the periphery. Bending stress max 0 at any point on the neutral axis. That is either on HCA or VCA. Vertical bending any point on HCA. Horizontal bending any point on VCA. But torsional 0 only at one point. That is the centroid. Centroid. Next. On a fiber. On a fiber. On a fiber, point to point, torsional shear stress will vary, but bending stress is constant. And what the another different now? Pure bending, you are going to get a uniaxial state of stress. Pure bending, you are going to get a uniaxial state of stress. But pure torsion is what now? Pure shear state of stress, biaxial state of stress. Suppose this is a tau xy. Tau xy is associated with what? Tau xz will tau yx will be there now. Here bending stress like this, only sigma x will be like this now. Only bending stress sigma x. But if a torsional shear stress like this now, this is what now? Suppose I have taken this, which one I have to call it now? Tau. Which phase now? Is a z phase. Tau zx. Tau zx associated with what? Tau xz will be there now. We have studied complementary shear concept now. So tau zx associated with tau xz. But if I take it at this point, this is a torsional shear stress. Now this will be what now? Tau xzy. Is a which phase now? Z phase. It's a z phase. So this will become as what? A tau zy. Here tau zx. Tau zx associated with tau xz. Tau zy associated with what? A tau yz. In one of the GATE's recent paper now, this torsion question is given. At this point is asked, at this point, what is the tau xy value? At this point, what is the tau xy value? 90% of students is given as what? A 16t by pi d cube. 90%. Answer is 0. One answer is given 16t by pi d cube. One answer is given 0. But everybody is taken 16t by pi d cube. 99%. Most of the faculty also given. Only except maybe what has given the correct answer now. But most of the students are what now? Challenge. Sir, maybe is given the incorrect answer. Sir, all other institutes they have given 0. Sir, sorry, 16t by pi d cube. It is in the periphery. Torsional shear stress maximum. How it is 0? He didn't ask the torsional shear stress. He asked the tau xy. Is the which phase now? This here taken z axis, z phase. And z phase, how many shear stress are there now? And z phase, how many shear stress are there? Tau zx and tau zy. Tau zx and tau zy. Then how you are going to get a tau xy? 0 directly now. Is the which phase now? Cross section is z phase. And z phase, how many shear stress are there now? Tau zx and tau zy. Now this will become as what now? Which axis now? X. So this is tau zx. This is tau zy. And tau zx associated with tau xz. So here how many stress will be there now? Only 2 stress. That's why pure shear now. Tau zx and tau xz will be there. Here tau zy and tau yz will be there. But in the question it asks tau xy. So who thorough with the what? Basics. Cross section given as a z phase. And z phase you will get it only shear stress is what? Tau zx and tau zy. But in the question is asking tau xy. Answer will be 0. This year also what? I completed a batch, prime batch, evening batch, Hindi batch. No. I given answer is 0. Sir, how it is 0, sir? It should be a 16t by pi d cube, sir. How it is 0, sir? It is the periphery. You are given the incorrect answer. He didn't ask the maximum torsional shear stress. He asked the what now? Tau xy. Always what you have studied now? This shear stress is like this. Tau. Which phase now? Z phase. Which direction now? X direction. Therefore the tau zx. Tau zx associated with the tau xz. That's why what the pure shear state of stress here written now? There I taken the x phase across section. When I taken the x phase across section, here taken tau x1 and tau yx. But here cross section is z phase. X z phase. On z phase, how many shear stress are there now? Tau zx and tau zy. Here it is going to be tau zx and here is the tau zy. First phase and direction. This is a direction, y direction. Is the x direction. So the last difference is what now? Pure bending, you are going to get a uniaxial state of stress. But pure torsion is a what now? Pure shear state of stress, the biaxial state of stress. And a pure torsion only what you have studied, a pure shear state of stress means what now? Sigma x plus sigma y 0. That all you have studied now. Now you can answer any of the question. I used to discuss this now, but nobody has focused that point. But that question not given in mechanical paper, that question is given in civil engineering paper. But on the same year, what now? Some batches, what by that time, GATE exam is completed now. GATE was conducted in the month of that, maybe 3-4 years back now, February. By that time, I already started, 2 batches have started, completed. Then I discussed the, after GATE exam is completed, I taken the paper, I asked the mechanical students now, who has attended my lecture now. Almost 30% of students given the correct answer, sir, is 0. So some questions are completely concept oriented. Completely concept oriented. So this or whatever I discussed now is a very, very important now. So try to make the already I discussed the pure axial loading and pure torsion. Pure axial loading, that is a very, very important. Next, day before yesterday, pure axial loading, pure bending I discussed. Now, pure bending and pure torsion I discussed. Pure axial loading, pure bending, day before yesterday. Now, pure bending and pure torsion. This is also a practical case now, because shafts are always subjected to bending and twisting couples are there now. But those who are not focused, then definitely what now? They will become as a mad now. Those who are not focused now, Those who are not focused on the basic, definitely what now? For the last half an hour I am discussing now, they will become as mad. Some friends are enjoying now. Some friends are what now? What is sir is discussing? In offline batch only what now? Some friends are what now? They will far away what now? Sir is asking something, my friends are telling something, they are communicating in a foreign language. I don't know what they are in which language they are communicating. Better to go outside, washrooms are going to be there, outside canteens are there. They'll go to the what now? Shuttling between the classroom to washroom and washroom to canteen. And they are going to what now? Triangular path they will make it now. Every half an hour they will go and come back now because they will not follow it now. But somebody may ask, sir, how do you know that? I am going to prove it now. But examination point, this is sufficient now. Next. Phi dash is the what? Shear angle. Phi already are used. I'm using the same notation everywhere now. Phi the what? Shear angle concept you have studied when you are studying the shear strain. Shear angle is the what now? By how much angle the left surface and right surface are gets distorted. You have studied the same now. Shear angle. Shear angle. Arbitrary point. Located at a distance of small r. Some of the students have asked now. Every student knows this torsion equation. The equation known to everybody. 100 students ask, 100 students know. Even midnight, 2 o'clock also ask now. Please wake up torsion equation. They will give it by heart it now. But what is your name? They may not suddenly tell it now in the midnight, 2 o'clock or 3 o'clock. They may forget about their name. But the equation they will not forget now. They will by heart now the equations. 100 students will give this equation. And ask, what is the shear angle? Sir, theta, sir. In this equation, only one angle is there, sir. So this angle itself shear angle now. This angle is the angle of twist. They know everybody know equation. But here what? Only one angle is there. This angle itself they are going to assume the shear angle. This is the angle of twist. Shear angle is different, angle of twist. What is the angle of twist you have studied now? Angle of twist is about by how much angle the cross section is rotated about polar axis. Yesterday I shown it also. Day before yesterday now. Angle of twist is about by how much angle the cross section is rotated about polar axis. Angle of twist different, shear angle is different. But they will remember, but in this equation only one angle is there. So assume that directly this is shear angle. When in workbook I have given a question on shear angle now. One faculty member is what now? It teaching the strength of material now. Last 5 years now. Some other institute. In joined the medicine now. Some other centers is taking. I used to take it only Delhi as well as Hyderabad only I used to take it. But it used to handle the, previously used to handle the what now? He has also published a textbook on strength of metal also. He has published a textbook on strength of metal also. And he's joined the what now? Medicine. and some other center is taking the strength of material. सर आपने वर्कबुक में एक क्वेश्चन दिया था सर, शेयर एंगल का क्वेश्चन दिया था सर, क्या शेयर एंगल क्या है सर बोल के पूछ रहा है. मीन्स he has published a textbook on strength of material and is teaching for last 5 years is teaching. And you don't know what the shear angle. And is asking me now, as stunned on the day now, how he has published a textbook and is teaching and you don't know what the shear angle. You don't know the shear angle, then what is going to teach the students? I don't know now. Simply take this equation now. Most of them are going to take this equation, they will solve the workbook question, they're completed. Students are very happy now. सर ने हिंदी में बताया था सर. Some, yes, cutting the jokes in sir. For some student need only Hindi. हिंदी में बताना है, जोक डालना है क्लास में, और बाकी टीचर में सम क्रिटिसाइज करना है हिंदी में. They are the best teachers now. And you have to complete the workbook questions. Problem देवो, equation देवो, problem कर देवो. Then they are going to be very happy. But when they're solving the problems, they will realize it now. So everybody is what now? Shear angle means angle of twist. They are going to take it now. Both are different now. Shear angle of an arbitrary point located at a distance of small r. Actually, this shear angle only proportional to small r. This only I'm going to show it now. This is the main reason. If I'm going to show from the torsion, I'm going to show it now. Actual reason is what now? Shear angle is proportional to small r. Shear angle is proportional to small r. This is what a phi max. Maximum shear angle. So where R is maximum of periphery. That is at any point on periphery. At any point on periphery. Tau t. So before this now, next gamma dash. What the gamma dash? Now gamma you are in for the shear strain. Shear strain. And directly this gamma dash equal to phi dash. Why now? What you have studied now? For smaller angle, shear angle equal to shear strain. When you have studied the shear strain, so directly this gamma dash is equal to phi dash. For smaller shear angle, shear strain equal to shear angle you have studied now. gamma max, maximum shear strain, at any point on the periphery, tau t, torsional shear stress, arbitrary point, located small r, tau t max, what is the reason now? But actually tau t is not proportional to small r. Which is proportional to small r? Shear angle is proportional to small r. Then how you have written that tau t is proportional to small r? By using Hooke's law. What is the actual reason now? I'm going to prove it. Shear angle is proportional to small r. As per the torsion theory, this is what now? Shear angle is proportional to small r. But you are writing what? Gamma dash is proportional to small r. What is the reason now? Because gamma dash equal to phi dash. This is the actual theory now. This is the actual what now? Shear angle is proportional to small r. This is because of what? Shear angle, nothing but a shear strain. Shear strain, nothing but the shear angle for smaller shear angle. Then we are in the Hooke's law. What is the Hooke's law now? Hooke's law will give the relation between the what? Corresponding stress and corresponding strain. That is, by using Hooke's law, tau is proportional to gamma. And already gamma is proportional to what now? Actually, what? Tau is not proportional to small r. This is the reason. This is the basic reason. As per the torsion theory, shear angle is proportional to small r. Then this is because of what? Shear strain equal to shear angle. And this by using Hooke's law. What the proportionality constant between these two? No, G. Tau is proportional to gamma. Already gamma is proportional to small r. Already gamma is proportional to small r. So this is the reason. That's why you have written tau t is proportional to small r. This is by using Hooke's law. This is by using the torsion theory. This is the torsion. This is the actual reason. This is the actual reason. So then what you can write down like this now? Phi dash by phi max This also, if you can call it as a dash, tau t dash. Means same as about a bending concept now. If I know bending stress 1 point, remaining all you can calculate. Same thing about now. If I know shear angle or shear strain or torsional shear stress 1 point, all you can calculate by using the linear variations. All are going to be calculated by using the linear variation. But this is the actual reason now. This is as per the torsion theory, this is the actual reason now. Somebody is asking once again, maybe logo issue is going to be there. Phi is equal to phi max. Maximum shear angle on the cross section. That is at any point on the periphery. Phi is equal to phi max, which is equal to maximum shear angle on the cross section. That is at any point on the periphery. At any point on periphery. So this is the important relation with this now. If you can know the either shear angle or shear strain or torsional shear stress 1 point on the cross section, remaining all you can calculate it now. Next one, write down theta dash. What is the theta dash now? Angle of twist. Angle of twist of a arbitrary cross section. Arbitrary cross section. Located at a distance of angle of twist of an arbitrary cross section located at a distance of small l. Or before this, now first write down the small l, write down. That is better. First write down the small l, because already I defined the small r. First write down the small l. Distance of a distance of an arbitrary cross section from fixed end. From fixed end. Capital L. Distance of faraway cross section. Capital L. Distance of faraway cross section from fixed end. That is free end. Which cross section is far away from the fixed end? Free end. So cross section to cross section, which value will change? Now L will change. Small l is 0. Small l is measured from the fixed end. At the fixed end, small l is 0. Or what the other terminology? This capital L is also called as what now? Length of the shaft under pure torsion. length of the shaft under pure torsion, length of the shaft under pure torsion, length of the shaft under pure torsion, length of the shaft under pure torsion. Then theta dash, angle of twist of a cross section located at a distance of small l. And theta maximum angle of twist. Maximum angle of twist of the shaft, R, is representing angle of twist of cross section at free end. What is the reason now? Theta dash is proportional to small l. Theta dash is proportional to small l. But what the angle of twist I not written? What the angle of twist you have studied now? Angle of twist is the what now? Angle of twist representing what now? By how much angle the cross section is rotated about the polar axis. What the bending and twisting you have studied now? Bending means rotation of a cross section about HCA or VCA. Rotation of a cross section about polar axis about a twisting. Rotation of a cross section about polar axis twisting. So by how much angle the cross section is rotated about its polar axis. By how much angle the cross section rotated about polar axis, the angle of twist. What is the angle of twist? Angle of twist is the angle by which the cross section is rotated about its polar axis. So now, angle of twist vary from cross section to cross section, or when you are studying the board, day before I studied the pure torsion, for all the points on the cross section, angle of twist is same. So angle of twist will not vary on a cross section, but vary from cross section to cross section. Angle of twist will not vary on a cross section. For all the points on the cross section, angle of twist same. If this is a fixed end, this is a free end. So when I am going to the fixed end to free end, what happens now? Cross section to cross section, angle of twist is going to be increased. At the fixed end, angle of twist 0. Free end, it is the maximum. So when I am going to the fixed end to free end, cross section to cross section, angle of twist is going to be increased. It is the maximum at the free end. It is the maximum at the free end. But on a cross section, theta will not vary. Theta will vary from cross section to cross section. But on a cross section, point to point, which one will vary? No? On a cross section, point to point, which one will vary? No? Shear angle, shear strain and torsional shear stress vary. Point to point, which one will vary? No? Small r will vary. Small l will not vary. No? If you consider cross section. Assume the cross section is the free end. It is a cross section the free end means for this cross section L is maximum now. L is maximum. On this cross section, how many points are there? Infinite points are there. So when I am going from here to here, point to point, which one will vary now? R will vary or L will vary? For all these points, which one is same? R is same or L is same? L is same. They are all on a cross section. What the L is representing now? Distance of a cross section from the fixed end. These are the free end. So this cross section at what distance from the fixed end? Capital L. So for all the points, what the capital L same? So theta is same for all the points. But all the points, which one is same now? Which one is different? R is different. R is 0, small r and capital R. Mean what the conclusion? On a cross section, point to point or on a radial line of a cross section, point to point R will vary, L will remain same. So when I am going to the centroid to the periphery, small r will increase, small l is constant. So shear angle, shear strain, torsional shear stress will increase, but angle of twist remains same. So for all the points, angle of twist is what now? Same, because L is same. That only I mentioned now. When you have shown it also 2D figure now. This is the initial position. After applying the twisting couple, what you have studied now? After applying the twisting couple, the cross section is twisted, rotated. This only called as the theta. So what this theta is representing now? Now all these points are rotated by same angle or different angle? Same. What this red color line? Initial position of the radial line. And what about this blue color line? After applying this is what now? Before applying a twisting couple. And the blue color line is about after applying a twisting couple. Because the cross section is going to be rotated like this now. In the clockwise direction, I'm assuming the twisting couple is the clockwise. The cross section is going to be rotated in the clockwise direction about which axis? The polar axis. So A is twisted to A dash, B is twisted to B dash, C is twisted to C dash. All are twisted by same angle or different angle? Same angle. Like this what now? You take any radial line. All are going to be twisted by the same angle. So on a cross section, point to point what now? Angle of twist will not vary. But which one will vary now? Shear angle varies. Once the shear angle varies, shear strain varies and torsional shear stress varies. Once again, what about this now? So what is this angle now? Theta. Once again, on this line, how many points are there? Infinite. Now once again, for all the points, theta is same. Like this, what now? Every point on the cross section is going to be rotated by an angle of theta. So theta is what now? Defined for a cross section means what now? For all the points on the cross section, theta is going to be same now. That's why I try to understand now. Theta is what now? Angle of twist of a cross section. For a given cross section, a constant. But what the angle of twist is representing now? By how much angle the cross section is rotated about its polar axis. Capital L is about length of the shaft under pure torsion. What is the meaning of pure torsion? Over that length, twist moment is going to be a constant. Torque diagram is a rectangle. Now with this one, you can answer all the questions. But some students are what now? This is sufficient for examination. You can answer all the questions, whatever I discussed now. But some students are what now? Sir, what the shear angle, what the angle of twist, or how shear angle is proportional small r, how angle of twist is proportional small l. So that I am going to prove it now. Otherwise, this is sufficient for the examination now. But only how you got it, that shear angle is proportional to small r, how phi dash is proportional small r, and how theta dash is proportional small l, I am going to show it now. Now, if somebody will ask now, can you explain this terminology? Everybody is going to tell it what now? So T the torque, that is clear, or a twist moment. J the polar moment of inertia. What the polar moment of inertia? They will not unable to define it. What the polar moment of inertia? Second moment of area of a cross section about its polar axis. That is a central axis perpendicular to plane of cross section. Actual definition is what? A second moment of area of a cross section about a centroidal axis perpendicular to plane of the cross section. And everybody is going to tell what now? Sir, the maximum torsional shear stress R is the radius. It is the incorrect. Just now you studied what now? Tau is depend upon what now? Tau is the what now? Torsional shear stress varies or constant now? Varies. Everybody is going to mention what now? Sir, the tau is the maximum shear stress, R is the radius. It is the incorrect now. Whenever you are mentioning the tau, what you have to mention now? Point you have to mention it now. So what this overall term I have to mention now? Don't tell what now? Is the maximum torsional shear, R is the radius. Don't mention it now. Just now you studied tau is proportional to small r. So what you have to indicate what this term is representing means what now? Maximum torsional shear stress on the maximum torsional shear stress develop at any point on the periphery. Periphery means automatically capital R. So whenever you are mentioning this one, what I have to mention, don't use individually. Sorry, the maximum shear stress or the radius. Tau is not a constant, tau is a varies. So what you have to explain this term means what now? Maximum torsional shear stress develop at any point on the periphery of the cross section, or otherwise torsional shear stress at any point on the periphery. Periphery means what now? Automatically capital R. So whenever you are mentioning the tau, you have to indicate the what now? Stress is defined at a point. Therefore, you have to indicate that point is located at what distance. So this much amount of torsional shear stress develop at any point on the periphery. Next, everybody is going to call the theta the angle of twist, L is the length of the shaft. Incorrect now. Angle of twist vary from cross section to cross section. So what do you have to mention this about the theta by L? Angle of twist of a cross section at the free end, or angle of twist of a cross section at the free end. Free end means automatically capital L. Don't mention theta the angle of twist, L is the length of the shaft. Either incorrect now. Theta is not a constant. Theta will vary from cross section to cross section. So when this, what this term means, what do you have to mention now? Angle of twist of a cross section located at a distance of capital L, or that simply can mention the what angle of twist of a cross section at the free end. At the free end. Now whatever the figure I am drawing, try to draw in your notebook little bit bigger in size. There are so many lines are going to be there. Then only this shear angle and angle of twist is going to be clear. This figure, whatever I am going to draw it, it will clear all your, just now what I explained now. How angle of twist is proportional to small l. How shear angle is proportional to small r. And what the difference between shear angle and angle of twist, these are all going to be cleared now. This is only for explanation. Otherwise, examination point of just now what I have written, that is sufficient now. But how we got that relation phi dash is proportion small r? How theta dash is proportion small l? For that one, this I am showing now. Bending equation you can easily analyze also. When you are mentioning what top surface length is decrease, bottom surface length is increase. So more change in length means more strain will be there. And more strain means what? More stress is going to be there. That you can imagine, you can visualize also. But here what now? We cannot clearly what now? Visualize the shear angle and angle of twist. That's why I'm showing this now. So I'm taking the 3 cross sections I'm taking now. ఇన్సెప్ట్ పని మిస్ అయింది వాయిస్. ఇప్పుడు వస్తుందా వాయిస్? చూడండి, నా వాయిస్ రావట్లేదా? My voice is audible now? Is it voice is audible? Is it voice is audible? So can anybody mention what now? At which time the audio is not off now? Anybody can tell it? I didn't check it. I was explaining continuously. Anybody can vote, inform me when the audio was not available. From which time the audio is not available. When draw the diagram from about when you are marking A and B. Don't mention the time. Try to tell me when you are marking the, when you have started the marking the diagram or making the diagram. Please clearly tell it. Upper line of diagram ABC. Somebody tell 11:20 at the start of the topic, sir. Don't tell me what the time now. Somebody is telling 11:10, somebody is telling 11:08, somebody is 11:26. Okay. So, my dear friend, I'm going to repeat it once again. First, I considered about now circular and prismatic member. Circular and prismatic member. O is about now. This is a fixed end here now. This representing cross section of the fixed end. Here L is 0. Small l is 0. Is a intermediate cross section. Intermediate cross section. For this one, L is small l. It is a cross section at the free end. That is far away from the fixed end. Far away from the fixed end. For this one, L value is what? A maximum capital L will be there now. Capital L is there. So these are the three cross sections are parallel. Because so far there was no load is applied. There was no load is applied. So initially all the cross sections are parallel. Then I taken a radial line. What the OA? OA is the radial line on the cross section of the fixed end. On a cross section, how many radial lines are going to be there? Infinite radial lines are there. So for this line, L is going to be 0. L is 0. And what about this O1B? Radial line on an intermediate cross section. Then here small l will be there now. And O-C is a radial line on the cross section at the free end. That is for this line, small l is equal to capital L. So these three lines are parallel. OA, O1B, O-C. There are three radial lines which are parallel. But L is different. L is 0, small l and capital L. Next, I consider about a line ABC. This line ABC is about now longitudinal fiber on the surface of the shaft. Longitudinal fiber on the surface. How many longitudinal fibers are there? Infinite will be there now. On a surface, how many longitudinal fibers are there? Infinite. This is also what? This finger is about a one longitudinal fiber. It is also one longitudinal fiber. This is the complete surface of this shaft now. Complete surface of this is what? A one longitudinal fiber on the surface. It is also one longitudinal fiber. Like this, how many longitudinal fibers are going to be there? Infinite will be there now. So I have taken a one longitudinal fiber. So this is a longitudinal fiber on the surface. For this one, what the small r value? No, capital R. On the surface means small r is a capital R. Next, what about the DEF line now? DEF line is the longitudinal fiber below the surface. That is at what distance? No, small r. Is the intermediate longitudinal fiber. Just like this, the intermediate cross section is the intermediate longitudinal fiber. For this one, small r is small r itself. And what about this O1, O dash? This red color line. A longitudinal fiber coincides with the longitudinal axis. Now for this one, R is 0, small r, capital R. Now once again, these three lines are parallel. Once again, these three lines are parallel. Now you have to study after applying the twisting couple. After applying the twisting couple. After applying the twisting couple. What changes are going to be happened in these lines? You have to study it now. What changes are going to be happened in these lines? You have to study it now. Now, how a twisting couple is formed now? I've already that line, this force, I removed it now. If only one ETSL is applied, then what happens now? It is not a pure torsion. Every ETSL equal to what we have studied now, one TSL plus one twisting couple. We are going to into the P1 inward, P2 outward. P and P2 will form a twisting couple and P1 will become the TSL. And due to P1, you are going to get a one shear force and one bendiment will be there. But I need a pure torsion. If only one ETSL, every ETSL equal to one TSL plus one twisting couple. Then due to TSL, you are going to get a shear force and bendiment. But I need a pure torsion, means axial load, shear force, bendiment should be 0. Then pure torsion is possible because the what now? Two equal parallel opposite ETSL. I have to apply one more ETSL. This is the inward, this is the outward. Top one is the inward, bottom one is the outward. So these two are forming a couple in profile plane. Seeing from the right side is the clockwise. Then double arrowed is going to be towards left side. Double arrowed is going to be towards left side. That already studied now. Couple is seeing from the right side of the clockwise. Then fingers are towards the board and thumb is going to be towards left side. So this I replaced by this now. So this only but now this couple is in which plane? Profile plane. Profile plane which acts with perpendicular polar axis. This is CZ. T is equal to P into D. Is the clockwise direction from right hand side. And what the reaction will be there? Now opposite direction. Anti-clockwise direction from right hand side. Anti-clockwise direction from the right hand side. Now check it out now. What type of loads acting on the entire member? Blindly you have studied. Whenever you apply the two equal and opposite twisting couple at the extreme end. Whenever you apply the two equal and opposite twisting couple at the extreme end, the pure torsion. Otherwise you take a arbitrary cross section. What the loads here now? What the axial load? Algebraic sum of the axial load on the right side. Right hand side there is no axial load. 0. What the shear force? Algebraic sum of the constant point load. There is no constant point load. 0. And what about the bendiment? Now algebraic sum of the bending couple are moments. Right side there is no bending couple and no constant point load. Bendiment 0. And what about the twistment? Now algebraic sum of twisting couple. This is what now toward the cross section is positive. Hence AL SF BM is 0 means ALD SFD BM is the line coincides 0. And torque diagram is what? A rectangle. So what this overall figure is representing now? What this overall figure representing now? Circular and prismatic shaft under pure torsion. That only are what now? Just now you studied what now? Therefore, left to right what happens now? Cross section to cross section what now? Neither material is changing, nor diameter is changing, nor shape is changing, nor torque is changing. So all the cross section, which one is same now? Diameter is same, material is same, torque is same. And all the cross section, axial load, shear force, bendiment and twistment, bendiment is 0. That's why in the torsion equation, what is written now? What the condition you have studied now? First of all, it should be a circular and prismatic pure torsion. Next, same material. Now what should I call this? What this L now? L is not the length of the shaft. All the low standard textbook they are mentioning the L is the length of the shaft. L is not the length of the shaft. L is the what now? Length of the shaft under pure torsion. Means here to here what now? Twistment is the constant. Length of the shaft means length between the bearings. Length of the shaft means length between the bearings. And not consider total shaft here now. I consider a portion of the shaft. Portion of the shaft which is under pure torsion. So this capital L is representing the length of the portion of the shaft which is under pure torsion. Now for that only I take an example here. Now remember what now? No power transmission shaft. No power transmission shaft. They are not under pure torsion now. For this only I take an example now. This was the question I was today discussed in the mains batch now. It was given one of the old engineering service paper now. The bearings and two pulleys are there now. Here power is received. Motor is placed below. Motor is placed below. So power is received. How much now? P. And here power is delivered to a lathe machine below. Below B, a motor is placed. So power is received by a belt drive. How much now? P. And below C, a lathe machine is placed. And power is delivered. So torque is received and torque is delivered. Torque here and here is same or different now? Power received and power delivered are same. How much power is received? P. How much power is delivered? P. And both are mounted on the same shaft. So omega is same, power is same, and torque is same. So torque at B and C is same. So that only I have shown it now. Torque here is what now? Here received and here delivered. And this question is asked what now? Find out the angle of twist of the shaft now. Everybody is taken what now? What this L now? L is the length of the shaft. But what the length of the shaft under pure torsion? Twist moment is constant over the entire length or only BC portion? Twist moment is constant only BC portion. So what this L by 2 is representing now? Length of the shaft under pure torsion. But what the total length of the shaft? L. But in the question is asked what the angle of twist. This is given as 1 meter, 0.25 meter, 0.5 meter. Everybody calculate the power. Torque calculation, everybody has done it now. Torque equal to power into 60 by 2 pi n. Diameter is given, G is given. And everybody is taken what now? L is the 1 meter they have taken. And the same question yesterday I asked, those who have attended my lecture, they have given the correct answer. But some of the non-medicine students are there now. There's somebody prepared on their own, somebody is about to attend the classes from some other institute. Non-medicine students are there now. But everybody is what now? They calculate the theta by taking the L is equal to 1 meter. Capital L they have taken now. Here what should I take the L now? Clearly mention L is the length of the shaft under pure torsion. In the torsion equation, what the L now? Length of the shaft under pure torsion. So twist moment is constant from B to C. Twist moment is constant from B to C. So in place of L, I have to put the L by 2. That is 0.5 meters I have to take it now. 0.5 meters I have to take it. So remember what now? In the torsion equation, L is not the length of the shaft. L is the length of the shaft under pure torsion, or distance of the free end from the fixed end. Now, I'm coming to what now? What the effect of this one you are going to study. This couple is a clockwise, anti-clockwise, clockwise. Couple is like this now. So cross section. This couple is about which axis? No, polar axis. So this cross section will rotate about polar axis in clockwise direction. Will rotate about polar axis in clockwise direction like this now. If you observe from the right side. So this is the initial position. Now after applying the twisting couple, the cross section rotated in the clockwise direction. Now can you tell me the position of C? Position of C when the cross section rotated about the polar axis. This C will be shifted above or below now? Above, because of what? A clockwise. Anti-clockwise what now? Anti-clockwise means like this now. Then the cross section is going to be what now? Rotated in the anti-clockwise direction. Then the point will come this side now. Clockwise means what? Like this now. Mean the point is what? Goes on the what? A cross section rotate like this. So the point is shift, goes on the back side or front side? Now back side. So I'm assuming what? Now this point is what? After applying the twisting couple. After applying the twisting couple, I'm assuming the what now? C is twisted to C dash. C is twisted to C dash. So this is a new position of this now. So this you are calling as the theta. But only C is twisted or F is also twisted by the same angle now? F is also twisted by the same angle. So what this theta is representing now? By how much angle the cross section at the free end is rotated about the polar axis. So now all the points are rotated by the same angle. So like this, I have taken only one radial line. Like this, how many radial lines are on this? Now infinite. So all the radial lines are twisted by the same angle. Means each and every point on this cross section is rotated by the same angle. Now, but what about this A? Is a fixed here now. This is a fixed end here now. So initial position and final position is same. So it's the initial position. Now what the final position now? What is this blue color line? Initial position of the radial line at the free end. And what this radial line now? What this red color line? New position of the radial line at the free end. So this, but here initial radial line and finally both are same. Then what the theta here now? Theta is 0. It is a fixed, it is not rotated now. So theta is 0. So fixed and theta is 0. Theta is going to be maximum. So what the angle between A and A dash 0? What the angle between D and D dash 0? Here also 0 now. Now what the new position of this line now? C is twisted to C dash. A and A dash is same. Now what the new position of this line now? So what is this blue color line now? New position of this longitudinal fiber on the surface. What the new position, initial position of the longitudinal fiber on the surface, ABC line. Now this is a new position of the longitudinal fiber on the surface. So now this is a new position of B dash. This is a new position of B. This I am calling as a B dash. Now what the new position of this radial line? What the new position of the radial line on the intermediate cross section? Now this angle is equal to theta, less than theta, or more than theta. Here theta is 0. Here this is a theta. This value is what now? Equal to theta, less than theta, or more than theta? Less than theta. This here called as a theta dash. What the theta dash terminology here written now? What the theta dash here written now? Angle of twist of a cross section located distance of L. So once again this theta dash, the angle of twist B or E, both are same. So angle of twist will not vary on a cross section. So theta dash as per the terminology is what angle of twist of a cross section located at a distance of L from the free end, so fixed end. So now what the conclusion you can make it now? Theta dash is less than theta. What the reason now? L is less than capital L. Hence, theta dash is proportional to small l. Theta dash proportional to small l. Here what the small l value is 0, therefore theta is 0. Here small l is maximum, therefore theta is maximum. So cross section to cross section angle of twist will vary now. It is going to be 0 at the fixed end, maximum at the free end. So when I'm going to the free end to fixed end, it will increase, but will not vary on a cross section. Always angle of twist remains constant for a cross section, but cross section to cross section it will vary. Previously I shown with the 2D figure, now I shown it here now. Now, what about this angle now? This angle is a shear angle. Shear angle. So what the shear angle? What the shear angle is represented now? By how much angle the longitudinal fiber on the surface is going to be gets distorted. When you are studying the shear strength, what you have studied now? Where phi is about now? By how much angle the surface on the left side and right side are gets distorted. So what this phi is representing now? By how much angle? This you are calling a shear angle. This phi is represented by how much angle the longitudinal fiber on the surface is going to be gets distorted. But this is the shear angle of what now? A or B or C? This is the shear angle of what now? This phi is about now? Shear angle of what now? A or B or C? All are same. Here to here angle is same. Here to here angle is same. So at A, angle of 0 or theta is 0 or shear angle is 0. At A, initially what A is on this line. Now this is end up here now. So this is a new position of initial position of longitudinal fiber. Is a new position. At A, theta is 0 or phi is 0. Theta is 0, but phi is not 0. This is about now shear angle of what now? Now you can see now here to here for all the point what the theta is same. Similarly here to here what happens now? Shear angle is same. So at A, shear angle is what now? Non-zero. How much now? Phi. Theta 0. At B, what the angle of twist now? Theta dash. What the shear angle now? Phi. At C, what the shear angle now? Phi. Theta is what now? So here when I'm going from along this line, along this longitudinal fiber A to C, along this line A to C, angle of twist is varying or shear angle is varying now? A to C. All the points what now? Shear angle is varying or angle of twist is varying? Shear angle is shear angle is constant, angle of twist is varying. Because for A, L is 0. Here small l. They are all what on the same cross section or different cross section? A, B, C are on the different cross section. So L is different. L is different means angle of twist is different. But shear angle is same because they are all on the same longitudinal fiber. ABC small r is same or ABC small r is same or small r is same. What the r value now? Capital R. Capital R. Capital R. For ABC R is same. L is different. Here L is 0, small l now. So for ABC shear angle is same. Angle of twist is different. Because of ABC they are lying on the same longitudinal fiber, but they are lying on the different cross section. Next, what is the new position of this DEF line now? F is twisted to F dash, E is twisted to E dash, and D and D dash are same. So what is the new position of this line now? Now this angle equal to phi or less than phi or more than phi or equal to phi. This is what now? Phi dash. What the phi dash you have studied now? Shear angle of a what now? Arbitrary point located distance of small r. What the phi dash you have written now? Shear angle of a arbitrary point located distance of small r. So once again this phi dash is representing the shear angle of DEF. So once again now phi dash is less than phi. Phi dash is less than phi. Now what the new position of this fiber now? What the new position of this now? Longitude axis will remain same. So what the shear angle? No, 0. Shear angle is 0. Here shear angle is 0, here phi dash, here phi. Means when I'm going to the centroid to the periphery, what happens? No, shear angle is increasing. Here shear angle is 0 because of r is 0. Here shear angle is what? A phi dash because small r. Here shear angle is maximum phi. So point to point what happens? No, on a radial line, point to point r is changing. The shear angle changes. Shear angle is increasing. When the shear angle increases, shear strain increases. When the shear strain increases, torsional shear stress will increase. So here what you have tried to know? Phi dash is less than phi. Phi dash is less than phi. Because small r is less than capital R. Hence, but the shear angle itself shear strain you call now. Shear angle itself shear strain. Then gamma dash is proportional to small r. And by using Hooke's law, what you can write now? Tau dash is tau is equal to what now? So now by using shear angle is equal to shear strain. Shear strain equal to shear angle. Then when the shear angle is proportional to small r, shear strain proportional small r. And by using Hooke's law what will state now? Hooke's law will state. So when the shear angle is proportional small r, shear strain proportional small r, then automatically tau is proportional to small r. Tau t proportional to small r. That only I have written previously now. Now theta, what the conclusion now? When I am going to the fixed end to free end, cross section to cross section, angle of twist will increase. Angle of twist maximum at the free end, 0 at the fixed end. And on a cross section, when I am going to the centroid to the periphery, shear angle will increase. Or we can call the what now? Fiber to fiber, longitudinal fiber to longitudinal fiber. When I am going to the like this now, longitudinal fiber to longitudinal fiber. So shear angle is going to be maximum at the longitudinal fiber on the surface. Suppose I am going to take the 3 points here now. PQR. For these 3 points, which one is same now? For these 3 points, shear angle is same or angle of twist same? For these 3 points, R is same or L is same? R is same. They are all on the longitudinal fiber. So for all these points, shear angle is same, but angle of twist different. They are all on the different cross section. Then what should I write down now? But they are all on the same fiber. Phi P is equal to phi Q is equal to phi R is equal to phi, maximum phi. Because but what about the angle of twist? Theta P less than theta Q less than theta R less than theta, because LP less than LQ less than LR, which is less than capital L. Mean what the conclusion of this PQR are taken on what now? Longitudinal fiber. Means on a longitudinal fiber, point to point what happens now? Shear angle will not vary, but angle of twist will vary. And before this now, Anybody, what this torque diagram is positive? What is the meaning of torque diagram? Bending diagram is positive mean what? Sagging mean what? No. Top surface gets contracted, bottom surface is going to be elongated. Here what the torque diagram positive means, everybody is going to, sir, double arrow toward the cross. That is for your identification. But what the torque diagram is positive. If ALD is positive mean what now? Tensile load. What is the meaning of tensile load? Member is going to be, length is going to be increased. If ALD is a negative mean what now? Compressive load. But what is the meaning of compressive load? Compressive load means what? Length is going to be contracted. BMD the positive means sagging. Sagging means what now? Top surface gets contracted, bottom surface elongated. Similarly, what the torque diagram is positive. Everybody is going to tell, sir, twisting couples are double arrowed toward the, that is for your identification. But what the meaning now? Here all this cross section rotate in the clockwise, anti-clockwise. All the cross section rotate in the same direction or different direction, same direction. It is also twisted in the clockwise direction, clockwise direction, clockwise direction. But they're all twisted by same angle or different angle, different angle. So what the meaning of twistment diagram is positive. All the cross sections are twisted in the clockwise direction, observing from which side now? Right side. If the twistment diagram is negative, mean all the cross sections are twisted in the anti-clockwise direction. So twistment diagram is positive means are twisted in, cross sections are twisted in clockwise direction. Twisted in clockwise direction. But they are all twisted at different angles now. If the twistment diagram is negative, but which direction is seeing from the right side? Default is seeing from the right side. If the twistment diagram is negative, mean all the cross sections are twisted in the anti-clockwise direction from the right side. I'm taking the 3 points here now. Previously, I have taken PQR. PQR is taken on a longitudinal fiber. Now, what about this CGF? CGF on a radial line. Now, for this 3 point, which one is same now? For this 3 point, R is same or L is the same? L is same. So, for all this point, angle of twist same, but shear angle is different. So, what the angle of twist at C, G, F is the maximum. What the maximum of theta? Because but what about the shear angle? Phi F less than phi G less than phi C. Phi C. Phi C is nothing but about a phi, maximum phi. Because RF is less than RG. RG is less than RC. RC equal to capital R. So what is the conclusion now? I have taken 3 points on a longitudinal fiber, 3 points on a radial line. So on a longitudinal fiber, point to point, angle of twist vary, but shear angle is same. Shear angle same and shear strain same and shear stress is same. But on a radial line, point to point, shear angle will vary, but angle of twist is same. On a given radial line, angle of twist is constant. Angle of twist is constant. But shear angle varies. Similarly, what now? On a longitudinal fiber, so far you have studied the fibers on a cross section. Top fiber, bottom fiber, left side fiber, they are all on the cross section. But the longitudinal fiber means what now? This is what now? Parallel to length of the shaft now. Parallel to length of the shaft now. On a longitudinal fiber, shear angle is constant. Sorry. But this is missing here. Angle of twist is constant. But shear angle varies. Here, shear angle is constant, but angle of twist varies. Angle of twist varies. So try to differentiate between the theta and phi. Now final conclusion is what now? Angle of twist and shear angle are independent or interdependent or what now? Angle of twist and shear angle. Angle of twist and shear angle are what now? Independent or interdependent. If it is interdependent, which one will depend now? Suppose I make the C dash here now. I assume the C dash here now. Suppose I taken the C dash here, theta decrease, then automatically theta decrease, phi will decrease now. So which one will depend upon other now? Theta and phi are interdependent. But which one will depend on other now? Shear angle will depend upon the angle of twist. Shear angle will depend upon the angle. But angle of twist depend upon the applied torque. If I increase the torque, angle of twist increase. When angle of twist increase, shear angle will increase. So shear angle and angle of twist are interdependent. But which one will depend on other now? Shear angle depend upon the angle of twist. But angle of twist depend upon the applied torque. If I increase the applied torque, theta will increase. When the theta will increase, phi will increase. When the phi increases, gamma increase and tau increases now. But do I need both the values or one is sufficient now? One is sufficient. If I know one value, other value can get it now. So what is the conclusion now? Shear angle and angle of twist are interdependent, but shear angle will depend upon the angle of twist. Shear angle is depend upon the angle of twist. But angle of twist depend upon the applied torque. If I increase the applied torque, theta increase. When theta increases, phi increases. When phi increases, gamma increases and tau is increases. Both are interrelated. But do I need both the values or one is sufficient? Now can you get the relation between the maximum shear angle and maximum angle of twist? What the relation between maximum shear angle and maximum angle of twist? If we consider this triangle ABC, what you can write down now? Because the board is going to be now camera is fixed, but I have to what now? Within this space only I have to write down now. ABC. What can I write down now? Tan phi is equal to CC dash upon AC. Somebody once again, they may ask about, now, sir, logo is going to be there now. Once I am repeating now, on a longitudinal fiber, shear angle is constant, but angle of twist varies. On a longitudinal fiber, shear angle is constant, but angle of twist varies. Angle of twist varies. So tan phi is equal to CC dash upon AC. But how to write down this arc length? Now this arc length is written as what now? R theta upon L. But for smaller angles, what do you write now? Smaller angles, tan phi equal to phi. For smaller shear angles, smaller values of phi. Hence, what you can write down now? So this relation, this is about a maximum shear angle, this is a maximum angle of twist. As per our notation, theta is about a maximum angle of twist. Phi is the maximum shear angle. Now I can see now for a given shaft, R is a constant, L is a constant. For a given shaft, R is a constant, L is constant. Once a shaft is manufactured, R is fixed, length is fixed. But this theta is varied. This theta will depend upon the applied torque. If I increase the theta, phi will increase. So do I need the maximum shear angle or maximum angle of twist? Any one is sufficient. If I know the maximum angle of twist, you can find out the maximum shear angle. If you know any one, you can calculate it now. Now, this phi is representing the what now? Maximum shear angle. This phi is the maximum shear angle. Which is equal to gamma max. Gamma max. So which can be written as what? R theta by L. Then how to write down the tau max? G into gamma max. G is equal to what? Tau by gamma. G is equal to tau by gamma. So from this one, what you are getting now? Tau max is equal to G R theta by L. So far here about the maximum torsional shear stress. Maximum torsional shear stress calculated by T by ZP. Now what the other way can calculate now? GR theta by L. Just like step bending now. Maximum bending stress calculated by M by Z and E Y max upon R. Similarly, the maximum torsional shear stress calculated by T by ZP, other one is GR theta by L. When should I the M by Z? When bendment is known. When should I the E Y max upon R? When R is known. Similarly, how to find out the maximum torsion? Two ways. T by ZP. When I know the torque, I have to use the T by ZP. Some question they are going to give the angle of twist. Then you have to use the GR theta by L. Now, from this only what we are getting now. If I bring the what now? R into denominator. This is only torsion equation second and third term. This is only torsion equation second and third term. If I bring the R this side, so tau max by R equal to G theta by L. But the torsion equation, no, T by J equal to tau max by R equal to G theta by L. Once again, this equation compulsory, optional. Optional. If you know this now, torsion equation, this is about the torsion equation I written now. This is equation known to everybody. This is equation known to everybody. So this equation compulsory or optional? Optional. If you know this one directly, can get it. Why not? If we equate these two, if I bring the g into denominator, if I equate b and c, if I bring the g into denominator, r into the numerator, what you are going to tau max by g. If I bring the g into denominator, tau max by g equal to r theta bell. What the tau max by g? Shear strain equal to shear angle. So whatever I had done it now, this is optional. If you want to able to remember, well and good. Otherwise optional now. But from this one directly can get it now. If you know this equation, if I bring the g this side now, r theta by L, what this term we are representing now? Gamma max. This gamma max itself what now? Phi max. So this relation is optional. If you are able to remember, well and good. Otherwise, if you know this torsion equation directly, you can get it now. But I proved it also here now. We got this relation now. So all these conclusions are valid what now? Circular prismatic shaft and a pure torsion made of same material. Now can you tell me now which one are the critical points here now? Which one are the critical points? Which one are the critical points in this shaft? Where the torsional shear stress maximum? For all these red color points, they are on the periphery of the cross section of the fixed end. The blue color points on the periphery of the intermediate cross section. Red color points on the periphery of the cross section of the free end. For all these black color points, blue color points and red color point, which is same now? Shear stress is same. They are also periphery. It is also periphery. It is also periphery. But all these points, which one is different? For all these blue color point, black color and the red color points, phi is same, maximum. So all these points are critical now. All these are critical. But if we join all these points, what you are getting now? If I join these blue color points, black color and red color point, what you will get it now? Top surface or bottom surface or entire surface. If we join all this red color, black color, blue color points, what you are getting now? Top surface or bottom or total surface, total surface. So which one are the critical points in the shaft now? Any point on the complete surface, any point on the complete surface. But pure bending what now? Pure bending what? Any point on the top surface, any point on the bottom surface. But pure torsion, which one are the critical points on the shaft now? Any point on the complete surface, any point on the complete surface. If you ask on a cross section, these are the critical points. If you ask on a cross section, any point on the periphery. Periphery should be used for the cross section. This is called the periphery. If you ask on this cross section, which one are the critical points, means any point on the periphery. But if you ask the entire shaft, when a shaft is under pure torsion, which one are the critical points in the cross section means answer is periphery. But which one are the critical points, the entire shaft means what the answer now? Any point on the complete surface. Like this now. If you ask on this cross, these points are critical. On this cross, these are the critical. Here, these are the critical. Now, this is what now? These points are critical on this cross section now. If I take a one more cross, these are the critical. Now, if we join all these points, what is this? Is a top surface. Is a left side, right side, bottom. So, this total is what now? Total surface. In case of bending, what happens now? In case of bending, when centroid is exactly at the mid, when centroid is exactly at the center, exactly mid depth, which one are the critical now? Any point on the top surface, any point on the bottom surface, in case of pure bending. But here, any point on the complete surface. Therefore, you should be careful now. Which one are the critical points under pure torsion means on a cross section, any point on the periphery. But if you have the entire shaft, which one are the critical means any point of the complete surface. These are also critical, these are also critical, these are also critical. If you join all these points, what you are getting now? Total surface. So critical points in the shaft are any point of the complete surface. Now where the torsional shear 0. If we ask on a cross section torsional 0 at the centroid, at O also 0, here also 0, here also 0. So where the torsion, here to here what? On the complete line, on this complete line, phi is 0. Phi is 0 means what? Gamma is 0. Gamma is 0 means tau is 0. Mean where the torsional shear 0? On a cross section at only one point. Which point? The centroid. But if you have the entire shaft, where it is 0, any point on the longitude axis. If we join all the centroids, what will get it now? If we join all the centroids longitude axis. Previously I explained what now? When I explained the terminology, I explained only with respect to cross section. But if you ask the entire shaft, which one are the critical means any point on the complete surface. In the shaft where the torsional shear 0, everybody is going to tell a centroid. Centroid should be used for a cross section. If you ask on a cross section torsional shear 0 at the centroid, but the entire shaft where it is 0. Any point on the longitude axis. If we join all the centroids, what now? Where it is 0 now? If we join all the centroid, you are getting a longitude axis. So torsional shear 0, any point on the longitude axis of the shaft. But what about the pure bending case now? Pure bending case, bending stress is maximum, vertical bending, and centroid is exactly at the mid depth. Bending stress maximum the top and bottom surface. But torsional shear is maximum the complete surface. But where the bending stress 0 on a cross section neutral axis. But if we have the entire beam, where the bending stress 0 neutral surface. If we join all the neutral axis, what you are getting? A neutral surface. So bending stress 0 at any point on the neutral axis of the cross section. But if we have the entire beam, where the bending stress 0, any point on the neutral surface. Try to correlate it now. Torsional shear 0 at the centroid of a cross section. Bending stress 0 at the any point on the neutral axis. But if you ask the entire member, bending stress 0, any point on the neutral surface, any point on the neutral surface. But torsional shear 0 only at the longitude axis. And bending stress is maximum top and bottom surface. I'm using the top and bottom because of default vertical bending. But torsional shear 0 maximum on the complete surface. Torsional shear is maximum the complete surface. So this is going to be what now? Almost half an hour. What I thought I want to give the break at 12 o'clock, but what now? In between that half an hour audio was not there. So once again I repeated. If this is clear, remaining is what a simple now. Remaining simple. Try to differentiate it. Try to differentiate what you are studying now. What the shear angle, what the angle of twist. Now the questions are simple. Those you understood now, they can answer any of the questions now. And one more point, you can see it now. This length of the line remains same or changes now? This is the initial position of the radial line. What the final length of the radial line? The initial position of the radial line, final position. Length of the radial line will remain same or changes now? Same. Length will not change now. What this length now? R. This length is also R. Means circular cross section will remain as a circular. But if you go for a rectangular cross section, what happens now? Because this is circular. This is circular. What this length now? R. Final length also R. So circular cross section will remain as a circular only. That what a plane cross section remain as a plane. But if you go for a rectangular or square cross section, it will not remain as the same. That's why the equation valid for what now? Only pure torsion. While deriving the equation, we are assuming that what a plane section remain in the plane even after twisting. That statement is what valid what now? The circular cross section remain as a circular because of what now? This length is R. Final length is also R. So circular cross section remain as a circular. Only that cross section is going to be rotated. Cross section is going to be rotated. But in case of rectangular and non-circular section, they will not remain as a rectangular. They are going to be distorted. The shape is going to be not the same now. Shape is not same. Now we'll take a break now. So this is what a very, very important if you are understood. Otherwise, simply I can take a torsion equation, you can do the workbook question now. But you cannot answer any of this thing. This is compulsory for what now? Even for the principal stress chapter also, critical point concept. So try to differentiate between the pure bending and pure torsion. I have already written. Discuss now, when I'm discuss the terminology. But there I discuss on the cross section. But if you ask the member what you had mentioned now, bending stress maximum on the top and bottom surface under vertical bending. But torsional shear stress maximum any point on the complete surface. Bending stress 0 at the centroid, nucleus of the cross section. Torsional shear 0 at the centroid of the cross section. But if you ask the entire member, bending stress 0 at any point on the neutral surface. If we join all the nucleus, you'll get a neutral surface. But torsional shear 0 at the any point on the longitudinal axis. If we join all the centroid, we'll get a longitudinal axis. Torsional shear 0 in a shaft, any point on the longitudinal axis, but on a cross section at the centroid. So we'll take a break. After break, you are going to continue it now. My dear friend, please write down now. So many times I repeated now. So many times I repeated. After spending so much of time, once again I am going to dictate it means what now? You try to write down. That's why I am repeating what so many starting I mentioned now. Everything I am going to repeat the minimum 2 times and 3 times. First time listen, second time write down. If I am repeating third time, we cross check it now. The difference between pure bending and pure torsion are differentiated. What 3 times I differentiated now. Now you can see any of the textbook, even you can see Farnatha textbooks, nowhere you are going to get this explanation now. Nowhere you are going to get this explanation this much now. This only the clear the concept of the students now. Then they can answer any of the questions now. So it is 12:40 will make a start at 1 o'clock. 20 minutes break is there. 1 to 3 o'clock we'll have the one more session will be there now. Because I have to complete the syllabus. I have already given some deadline is there. So I have to complete it. So we are going to make a 20 minutes break. So today it was anyway you are generally are reading up to 12 o'clock. But today it was extended almost 4.5 hours class is there. Because in between that audio problem was there. Okay. Thank you one and all. We'll meet at 1 o'clock.